So I'm going to talk quite fast because I am on a clock right here at 14 minutes to go. So primary purpose for me is to try to talk to you about some of the key decisions on architecture that we've decided on at LinkedIn over the past few years, what we did in 2014, and what we're planning to do for 2015. So a lot of information in that speed. So design, I'm not really going to focus a ton on design today, mostly on technology. You can sort of see the evolution of design. That's 2010, 2011, 2012, 2013 of the primary LinkedIn app. So let's talk about tech. We'll talk about the first chunk, 2010 to 2013. One of the biggest changes that we went through is when I started in 2010, we were using mostly Rails, Ruby on Rails. We were all process-based systems, which means every request spawned up a new process or a new thread. And we've pretty much almost fully moved to evented systems, not only for the mobile side, but also for the desktop side. Mostly because we found that our front-end systems were almost all I/O bound. That's primarily what they were doing, is talking to other downstream services, mid-tiers and backends, to be able to retrieve information and format it. Second big thing that we did, this was once again over a couple of years ago, is we moved from crazy branching model to trunk release model. So that literally was our branch structure at some point. And the trunk release model with the lines along it is really simple. There's a trunk, and we take pretty much cuts at certain points in time and then use that to release. People always say, well, how do you stabilize it? What happens? I don't understand, because branches are gone. That's how you stabilize the environment. Runtime flags. Now, the runtime flags literally are server configurable, and we can ramp them. We can ramp them to like a certain percentage of people, or even certain demographics of people, or even certain device types. All of that is server configured. And then we enable and disable features and then measure the impact, both product as well as operational impact. Third big change that we went through was we went with the whole web view approach, all the HTML5 stuff. Then we went native. Whenever I say this, people assume I ditched HTML5. We did not ditch HTML5. We went native, which means still in mobile web and the desktop web, we use HTML5. We have Objective-C and obviously Java for Android. There's actually another big change that we went through, something that we built called Superblocks. Superblocks are an important part of how we access all of the data at LinkedIn. As we started to scale the company up and we had more developers, we had to change the architecture to be able to provide large domains that were, operable units. So our profile, the feed, contacts, our graph, and we called those big things Superblocks. And they had three primary sort of purposes. One is that they were a single operational unit, which means independent of how many servers or services there were, when people talked about them, is this up? What is the, total QPS coming to this, or how is the system running? They talk about it as a group. If you're inside the group, obviously you know all the nitty-gritty details of how that system. What that means is profile Superblock cannot call the feed Superblock. This creates all sort of spaghetti. But having this separation of concerns and having separate Superblocks makes it very clean. And it's the final authority of data for whatever data domain that it owns. Second big change we made was we moved from a variety of RPC mechanisms between our server-side architectures into one standard RPC mechanism called RESTly. You can actually go to http://rest.li and you will find RESTly. It's open source, and you guys can use it at any point. Primary thing here was to go URN-based for all of our resources. HTTP is the actual transport, so it's easily traceable and debuggable. It has a self-documenting API. We have something called dynamic discovery. So this removes the need to have sort of either software or hardware load balancers between the mid-tiers and the Superblocks, or between the app servers and the mid-tiers. It talks to a Zookeeper instance, retrieves the list of systems that support that URN base, and then it talks to whichever one is necessary at that point. It also does decoration, which means, let's say you talk to profile. I just told you profile and feed can't talk to each other at the Superblock level. So let's say you retrieve the feed. The feed says, here are all of the activities. And each activity has somebody who actually made the post, for example. Well, the Deco library takes that information and will fill in all of the data for you. We call that decoration. The other big benefit that RESTly gave us is effectively testable interfaces. So let me show you what a RESTly example looks like. On the left, we talk about cookie.pdsc, which sort of defines a simple cookie resource. And then CodeGen is cookie.java, which allows you to create a place for you to actually implement what a cookie class would do. You would then implement like a cookie resource.java. You can also find all of this on Restly, so don't worry about taking it all down. You implement a resource getter, like a cookie get, which goes and gets it from my cookie jar, which is my database. And you then send the response back. That automatically generates a REST spec with the route and all of those capabilities. And you notice the documentation is sort of built in to the REST spec, and it's actually grabbed right out of the comments from the Java file. Right at the top, the comment is actually blocked into your doc. So that was 2010, 2013. We did Evented. We went with trunk-based development. We switched to native. We had Superblocks implemented, and we switched to Restly as our primary RPC mechanism for all interactions. So what happened in 2014, which is this year, and what is still happening? One of the big changes we went through is we went to a train release model. So what does that mean? All of our releases, all of our mobile releases are on a model where we pre-pick the date and time of exactly when it was going to release. We did this for the entire year at the beginning of the year. And what happens is the train is going to release no matter what. And we use the feature flags to decide whether or not your feature is on the train or off the train. It's a very simple model. One of the big benefits, there are actually a few big benefits to the train release model, which I'll get to in just a second. But one of the things that really confuse people about the train release model for server development is we actually release the train even when there's no code change. So people say, well, that doesn't make any sense. Why would you do that? Because there's a lot of other things that change that is not just your code. For example, tests, the build and deployment machinery, the operating environment, the container, any configs that might have changed. So just because your code hasn't changed doesn't mean the environment it's going to build, deploy, and run in hasn't changed. And so it's really important to continue the release cycle no matter what. So some of the pros, everyone's on a clear timeline. Everyone feels there's progress, and the velocity feels like it's growing, and there's a high focus on testability and quality because you're guaranteed a certain release cadence. The cons, just because the code shipped into production doesn't mean your feature shipped into production. It still has to be feature flagged on and ramped up slowly. And once again, everybody feels progress. That doesn't mean there's actual progress. Sometimes people just feel that there's progress. So this is actually a really interesting learning to figure out how do you measure rate of feature ship when it's separated from rate of code ship. And the more you actually end up more planning if your rate of train releases slows down, if your schedule isn't frequent enough. For example, our server releases 2 times per day. And our cadence for our releases on clients is monthly. One of the other big things that we've been focused on this year is something that we call Mobilize. We started off with about 30 people who were originally doing iOS and Android development. Now we're close to well over 200 people. We've put them through iOS and Android training, a week each for both, and then actually had them go through an apprentice program where they fixed bugs and shipped something on one of the trains before they were allowed to say that they were fully certified and prepared. The other big thing that we've done is actually take our platform, which we started out with just one library, and built out a large number of libraries. So authentication, networking, tracking, cross-linking, cross-promotion, deep linking, terms of service, RUM, crash libraries. And we're like, oh, this is all of them. And what we're starting to see now is that people are starting to build even more libraries for mobile. Registration, payments libraries, search libraries, where you're actually doing some of the search, the smart search indexing on the client side, image libraries for image manipulation. And this list is actually growing. We also launched a large number of apps. Most people, when I tell them that we have more than one app, people are surprised. So if you look, we actually launched 4 more applications this year. So what were the key learnings that we got? This is one of the key learnings. One is everybody says, well, web, and then there's mobile, and then what's expected is mobile's going to take over the web. Well, in reality, that's not what happens. Everybody, at least on LinkedIn, ends up using them about equally throughout the day. And that created some issues for us, and I'll talk about how that changed our technology architecture. Second big learning, the multi-app world really allows us to be able to build and deploy, and each of them to have their own train schedules. But growing these new apps is really, really hard. So we have to focus on cross-promotion. So this is an example of a cross-promotion. You can actually use on iOS or Android to check whether another app is installed, and you can then decide whether or not you show a promotion like this to go get one of our other applications. The mobile platform, which is the series of libraries that I talked about, is actually really, really important. Those libraries end up being the basis of us being able to build multiple applications at cadence at speed. And the product metrics are actually very different for each app. A lot of times you measure an app and you say, well, this is how much usage it gets, or this is how much engagement it gets. But if its revenue model is actually based on enterprise sales, how much engagement it gets isn't the primary way you measure success for it. So having very different metrics per business or per app was another big change to the back end that we had to go through. So that was 2014, where we went to the train release model, and we're really taking it forward there. 2, we mobilized. And 3, we went to the multi-app strategy. So what's happening in 2015? Where are we headed? 2015, here are the things that we've decided we're definitely going to keep. Moving to an evented model. We're currently still Node.js based for all of our mobile stuff, but our web architecture has moved mostly to Play and Scala. And we're looking at how do we merge those two and figure out one evented framework that's going to be our future. The second is we're going to keep our trunk release model. And the third, we're staying with native development. We are not going back to sort of the web-embedded WebView model that people keep hoping that we're going to get to. What are we going to double down on? The train release model. This has actually really, really worked for us, and we're trying to increase the release cadence. We use this metric called 3x3, which is 3 releases a day of your server with no more than 3 hours from code check-in to code release. This is significantly harder to do than to say. A lot of it comes down to testability metrics, and we'll have another. You can actually find some information on our LinkedIn development engineering website to actually find how we do some of this work. And then what are we evolving to? Here's what our architecture looks like on the left right now. We have a phone server, a tablet server, a home, which is our homepage server, a profile server, and a bunch of different clients. And we are trying to move to the model on the right. We call those things application blocks. We're modeling this very similar to how I talked about superblocks. So instead of just back-end domain-based blocks that are operationally central, these application blocks are one-to-one equivalent to applications in the multi-app strategy. That's across platforms. They're a single operational unit. There's no sideways calls, which means one front-end server should not be calling another front-end server. And they're the authority of presentation models, which are the UIs that are used, the models that are used to represent the UIs. Second big change, which is the same thing that we did on the back end, is we're moving to a structured JSON model, pretty much RESTly, where we have URN-based resources between our client and our server, using the HTTP transport, using the self-documenting API, and actually doing code gen, even for Objective-C and JavaScript, so that we can actually generate the client libraries that can talk to our servers. This creates much more testable interfaces and allows us to effectively scale our development cycle for the multiple applications. And then last, we're actually adding APIs, which are URLs between applications. Structured URLs that are documented, backward compatible, they're cross-platform, and they provide isolation between the applications. These are the public URLs that we'll share with you. So /profile/ a member ID at LinkedIn should work on mobile, should work on iOS, should work on Android, should work on the desktop. And those application separations and the actual URL separation is the primary difference that allows us to get scale as we move to a multi-app world. The final part for 2015 as we look at it is application blocks, the PDSC stuff I talked about, and the URL APIs. And that is just under a minute for speed talk. I think while they're setting up, I can take a question or two. Do you guys have any questions? Yes.
What do you wish you didn't do last year? For example, either way.
Yeah, so one of the big things that we tried to do is actually we tried to do decentralized development of mobile, where we literally had about almost 150 people check into the iOS code base of a single application, of our main flagship application, and same thing on the Android side. That ended up causing a lot of complexity and code bloat that is very difficult to maintain in the long term. I think in hindsight, what we should have realized is the single-use applications and the multi-app strategy is what we had to have invested in. So the training was key, but I'm not sure dumping 150 people into a single code base scaled.
And we'll have time for questions. we'll have time for questions at the end. So that's thank you, Karen.
Yeah.
Hi, I'm David. I'm from Facebook. I'm going to talk about trying to dump 150 people into one code base and making it scale. Specifically for Android, using a technique that we call exopackage. Before I get into the details of what that is and how it works, I need to provide a little context about what it comes from, which is our build tool called Buck. This is a build tool for Android and other types of software that is developed at Facebook, but it's an open source project. You can find it on GitHub. And a question you might have is, why did Facebook develop its own build tool? Why didn't you just use what was out there? So for those of you who are not super familiar with the Android build environment, here's a quick tour. One option that's out there is Ant. How many people use Ant for their Android builds? I see a couple hands. This is the official build system that's supported by Google for Android. Our experience with it was very slow. The other thing that we really didn't like about it is that it has very poor support for modularity. If you want a portion of your source code to be treated as an independent module, it has to basically have its own source tree. You have to update a lot of class paths. There's a lot of boilerplate. To give it a sense of our impression of the speed, one of our scripts, when we were converting to Buck, printed this message that said, you can download, install, and build this app with Buck in less time it would take you to just wait for this build to complete with Ant. That was very effective at getting people to switch over to use Buck. Another option is Gradle. How many people are using Gradle for their Android builds? A lot more hands. Awesome. So this is the beta build system that's provided by Google. It is not their officially supported option. It only recently went from good luck to beta a couple months ago at I/O. It's definitely faster than Ant. It still has pretty mediocre support for modules. You still need a separate source tree to get your source to be sort of treated as a separate unit. And if the question is, why didn't we use Gradle instead of Buck? Gradle didn't really have any meaningful Android support when we started, so it wasn't really a consideration for us. Now that Gradle does exist and has Android support, we could consider switching to it. But I hope the rest of this talk will convince you of why we don't think that's what we want to do. The other option is Maven. Does anyone use Maven for their Android builds? I see one hand in the back. This is not an officially supported thing from Google. It's extremely slow, and we don't like it at all. So that basically led us to create Buck. We were using Ant. We were doing what Kieran referred to as mobilization. We were getting more people developing native code on Android. The builds were getting slower with Ant. We have a lot of engineers. They write a lot of code. The main Facebook for Android app has over 650,000 lines of code. That's a pretty conservative estimate. That's the number of executable lines of code in our production release build. So depending on how you count, that number could be higher. And Buck helps us build it quickly. But a lot of the optimizations that Buck does for our large app will also work for smaller apps. And I have some numbers on that in a little bit. So as you might have guessed, Buck's focus is speed. We've seen about a 10x improvement in the median build time of our main Facebook app over the last year. So this is not comparing Ant to Buck. This is just comparing Buck from a year ago to Buck now. And this does not control for the size of the app. Obviously, our app has increased in size during that time, but still the overall absolute median build time has gone down about 10x. We have a lot of important optimizations that allow this to happen. The first one, which has really been in Buck since the beginning, is that it has good support for high granularity modules. We have one unified source tree for all of our Java code, and individual parts of it can be made into sort of standalone modules that get built independently just by dropping a Buck file into that directory. So in many cases, an individual Java package gets compiled as a separate unit. This also allows us to do a lot of parallelism in our builds because each module can be compiled in parallel. We do what we call an ABI optimization. So if you do a build and then you change some Java code and build again, Buck is able to detect whether you change the interface of the module or just the implementation. And if you only change the implementation, we don't have to recompile any of the other Java code that depends on the part that you changed. When you build an Android app, your Java files are compiled to class files. That's a standard Java thing. And then before those class files can run on an Android device, they have to be converted into a different format, which is called DEX. Android has a tool called DX that does this. And then at the end of your build, you merge all those DEX files together. And DX does have support for this, but it's relatively slow. So Buck has a custom version of DX in it that has a much faster algorithm for doing the merging. We run Buck as a daemon. Gradle also has this option, but it's not enabled by default. It basically means that you run Buck and it stays around in the background and it's ready for you to do your next build. This is a big help for build tools that are written in Java themselves. So specifically Javac, the Java compiler, and DX, which creates those DEX files. Those are both written in Java, and by keeping them resident in memory, we get to preserve the work that Hotspot did to JIT that code during your first build, and then when you do your second build, it's already pre-JITted. So this has a huge impact. It depends on the build specifically, but I've seen this have a 3x impact increase in build speed from doing the exact same build, the exact same work, just by having the stuff pre-JITted versus not pre-JITted. The last major optimization in this first generation is a distributed cache. So we have these high granularity modules that are always being built by our continuous integration server, and it uploads those results to a distributed cache. And then individual developers, when they do their builds, they don't have to rebuild all that stuff from scratch. They just pull down those cache results. So if you have been away from the office for a week, you check out the latest master and do a build. If you're in the office, it can take 20 seconds or less to do that full build. Even though you have nothing local, it just pulls it all down from the distributed cache. So these are a bunch of improvements. These helped our times a lot. Once they were all done, what was still slowing us down? Well, we identified two big things that were still problematic. And those are APK Builder and the installation process. So APK Builder is part of the Android SDK. If you use Gradle, this is what's referred to as the package debug step. And it's basically a process that takes your assets, your DEX, which is your compiled Java code, and your native libraries, and just sort of smushes them all into one file, which is your APK. That's the final app that you install on your device. This can take 7 seconds or more for large apps. It's basically just proportional to the size of your app, because it just has to cram a bunch of files together. The next step that's really slow is the actual installation of that app onto a device. So this is done over ADB, and the ADB protocol maxes out at around 5 to 6 megabytes per second, even if you're on high-speed USB. So if you have a 20 or 40 megabyte debug build of your app, this can take a very long time just to copy it over. Once it's already there, the package manager has a lot of work to do. It has to copy the APK into place. It optimizes your DEX. It expands your native libraries. It verifies signatures. I don't know what else it does. It takes a really long time. This entire process can take anywhere from 2 to 45 seconds, depending on the size of your app and whether you're using a physical device or an emulator. The physical devices take longer than high-speed emulators. So this totally sucks. Our developers are really unhappy about waiting this amount of time after they make a one-line change to see that code running on the device. They hate waiting. So to explain how we avoid these steps, I have to take a quick digression. How many people are familiar with the 64K DEX method limit by show of hands? A decent number. How many of you were happy to learn about this when you first did? I see more than I expected. Wow. I was certainly not happy when I learned about it. Basically, when DX combines your class files into this DEX file, every method in your app needs to be assigned a unique 16-bit identifier. And if you have more than 65,000 or so of these identifiers, it just throws up its hands and says, I can't build your app. And you see Stack Overflow posts and bugs filed against the Android open source project. DX crashes on projects with greater than 65,535 methods. That's basically the long and the short of it. The important thing to realize is this isn't just methods that you define. It's any method in the framework that you reference. Anywhere in your app needs to be given an ID. So for example, if you look at this little snippet of code, we have one method being defined here. There are actually 8 method references on this slide. I challenge you to try to count them. I got 7 right and 1 wrong when I tried this. The point is that they can sort of sneak in where you don't expect them. Another thing that can cause your method reference count to go up really quickly is importing any third-party libraries. They tend to have a lot of features. You might not be using all of it. So for example, if you want to do something as simple as receiving push notifications in your app, you'll go to the Android developer documentation site. It'll say, oh, you need to use Google Play Services in your app. Put these 2 lines in your build.gradle file. This adds 29,335 method references just from these 2 dependencies. If you actually do this, you'll see your count go up by a smaller amount than that, because some of that overlaps with what your app is already likely to be using. But the fact that just using push notifications basically takes you halfway to the cliff from 0 is not really a good sign. So there's a couple ways to mitigate this. One that's very common is ProGuard. ProGuard will find bits of your app that are not referenced and strip them out automatically. This is extremely effective for third-party libraries because if you're only using a small piece, there's a lot of stuff that's unreferenced that can be removed. The bad news is that ProGuard is a little bit slow, even in its most simple stripping modes. So you really don't want to be running this on every single debug build. It'll slow you down a lot. Another option is secondary DEX files. How many people have tried out secondary DEX files in your apps? I see a few hands. There's this blog post from 2011 where people were apparently already hitting this issue that explains how you can pull some of your code into a separate DEX file and they get separate IDs. You load them at runtime with reflection. It's a little bit inconvenient. So we dealt with all this at Facebook a while ago. The support that we built into Buck, basically what it does is it takes, use this fancy laser pointer. It takes all your classes that are supposed to go into your app and splits them up into different sections. So you have this little one at the top, which is your bootstrap code. That's what's necessary for loading up these secondary files, and puts the others into these chunks that are sort of independent. They all get converted into this DEX format independently and then get packaged into the APK. So the bootloader code becomes your main classes.dex, and the secondary DEX files become these assets. That whole thing gets copied onto the device. So that was how we got around the DEX method limit. That was built into Buck a while ago, and while it seems unrelated, it's actually sort of the secret of how we were able to speed up these builds by a substantial margin. So here's a zoom in on the two steps I was talking about before. APK builder on the left, where you're producing the APK, and installation on the right, where you're putting it on the device. This is the before picture, and the sort of magic sauce of Exo package. It sounds very simple. It looks like this. Basically, the secondary DEX files get removed from the APK. They don't go into the package at all. The APK only contains your classes.dex, your bootloader code, and also your native libraries and resources. That gets installed the same way it always did, and your secondary DEX files, which contain the bulk of your Java code, get side-loaded onto the device through a separate mechanism that doesn't go through the package manager. It does still go through ADB. And this is an optimization that we do on debug builds only. Obviously, you can't just like send these secondary files to users' devices, but for debug builds, it's very easy to just install it directly on the device. So this is obviously a very simple change, but it has a huge impact on the performance. The APK builder step is only necessary if you change something that actually goes into the APK. So this is your assets, your native code, or your bootstrap code. If none of those change, if you're only changing your sort of run-of-the-mill Java code, you can skip the APK builder step entirely, and that saves you about 7 seconds. The other thing is that the installer is relatively smart. It'll only install the files that actually changed since your last installation. So if you didn't rebuild the APK, that means you also don't need to install the APK. You can skip the package manager entirely if you're only changing your Java code. And this has an even bigger effect if you're using Art, because on Art, it does a lot more pre-optimization during the installation. And if you can install a smaller part of your app, then you can skip some of that pre-optimization and your install goes even faster. And so the other thing is that in our production app, we sort of artificially reduce the size of these DEX files and increase their number so that when you only change one, only that one needs to be reinstalled. And so instead of copying over all of your DEX files, we can only copy over maybe 10% of the content, which takes about 10% of the time. The result of this is that it is absolutely possible to achieve a 4-second build plus install time with Buck, even with a relatively large app. So this is not our average build time. It's substantially larger than that. But you can definitely, if you're iterating on a bit of Java code that's in a relatively small module, you can see this very frequently, 4-second build and install time. And that has a really dramatic impact on the way you develop code when you can iterate that quickly, making changes. In practice, we see about 60% of the time we're able to take the fast path of installation and skip the APK install entirely. There are a lot of cases that cause you to have to reinstall the APK if you are changing any XML, if you're changing any native code, if you rebased and you pulled in a bunch of days worth of changes from your code developers who changed XML code, if you grabbed a new device that hasn't had an install in a while. But even being able to eliminate the slow path in 60% of cases is a really big win for us. So FBForA is a relatively big app. What about a smaller app? There is an open source podcast app for Android called AntennaPod, which is a fantastic app, by the way, if you're interested. As a demonstration of this stuff, we ported its build from Gradle to Buck and did some apples to apples comparison. And basically what we saw was that with Gradle, this relatively small app, this 30 to 40,000 lines of code, had about a 20-second incremental build plus install time, whereas with Buck, it was about 3.2 seconds. And as your app gets bigger, that number on the left is obviously going to go up. Your builds take longer, your installs take longer. The great thing about the way Buck does DEX merging and Exopackage and all these other optimizations is that the number on the right stays relatively constant. For Facebook for Android, it's more like in the 5 to 6 second range. But for an app that's substantially larger, that's not that big a difference. In the future, one of the issues with Exopackage right now is that it only pulls your Java code out of the APK. If you make any changes to native libraries, images, XML layouts, those still require an APK installation. I'd love to see the native libraries and images pulled out of the APK so that the resulting APK is a lot smaller, and so even when you do have to install it, it's a lot faster to install. The other thing that would be really cool is if we could do something like Exopackage for XML layouts. It's a lot more complicated because of the way the layout inflator handles tracking where these things came from, but it could be a huge productivity boost for the people who are editing XML. So if you want to learn more, Buck is on GitHub. There's an article that's specifically about Exopackage and how it works, and has like a step-by-step walkthrough of how we ported AntennaPod to Buck and got Exopackage working with code, so you can replicate this experiment or try it on your own code base. That's all I got.
So, why don't we take a few questions while Paul comes up to give his talk. Hey, Paul. So questions? Right over here. I was blinded.
Sorry. Do you have a plan to integrate those very cool technology into Gradle so that most people who still use Gradle can benefit from your technology?
I think the thing that we're more interested in is making the things that are convenient about using Gradle work in Buck so that people can port to Buck. I didn't actually anticipate this question. There are a couple of issues that are difficult. One is that the multi-DEX support is actually a much more complicated change to the way Buck works than the Exopackage stuff. I think getting that to work in Gradle would be a lot of work, and the later optimizations like Exopackage aren't really that beneficial until you can get those earlier ones right. And the second issue is that the smart installer that actually sees what you actually have already installed is it's pretty important for that to work properly in order for this optimization to work. And that is another chunk of code that would have to be ported into Gradle. It would have to sort of know about the process of installing onto a device in a way that it doesn't right now.
Cool. Right here.
You ready? Oh, okay.
Hey, I wonder if you've put any effort into NDK support for native libraries?
Yeah, so we don't do that much native code at Facebook. We do some, and so the native support in Buck is lagging a bit behind. We're trying to improve that, and one of the things that I think would be really cool for us to do is, like I said, pull the native libraries out of the APK, just like we did with the secondary DEX files. That's actually it's probably easier to do than it was with the DEX files, and once we get that, you could basically get into a state where you are basically rsynching your native libraries onto the device. You don't touch the APK, you don't touch the DEX files at all. That's if you're just developing the native code. And so I think it is possible to see times like this with native code with those optimizations.
Any other questions? Are you ready to go up there?
I think so.
Okay.
All right, thanks a lot.
Cool. Thank you. All right. Looks like we're ready to go. Perfect. So I guess first off, how many people got from the airport or from their works to here using Uber? Nice. That's awesome. I'd love to see that. So really excited to be here talking about scaling a mobile-only company. This is something that we use internally, this talk of mobile-only, because you hear a lot of people saying mobile first. But for us at Uber, this is almost 100% of our traffic comes from mobile. When I gave this, when I sent this keynote to my team, they told me I should add a slide to introduce myself. So I'll start that. So I'm Paul, Senior Engineering Manager at Uber. I was one of the very first mobile people there, started several years ago. Here's the one slide about me, Canadian, like a lot of you guys, came to Silicon Valley to find crazy challenges, a lot of opportunity. I spent some time at Apple. So I went over there and in 2005 and joined the iPod team, and then quickly ended up on iPhone. I worked on iPhone from 1.0 until 5.0 and the apps and frameworks team, so that was a lot of fun. But this is more fun. So Uber, this was a really interesting jump for me. When I talked to the folks there for the first time, I think one of the things that really excited me about Uber was the fact that I had no idea how I was going to do this. This idea of taking mobile and scaling both a product and scaling also a logistics company was going to be just crazy, right? So joined them, really confused, but really, really excited to take on some of these things. So I'll go through some of the big challenges that I saw there in the first couple of years, and things that, Uber's a really young company. I think we've got through a few of these. I think a few of these we're still really trying to figure out and break through, and we've got some great ideas, and hopefully we'll be able to execute on them. All right, so this was the first couple of months of my career there, was when we really started expanding around the US and internationally. And the model worked fairly well, right? We had a business in San Francisco, we had a business in New York, we had a business in Boston, in Chicago. I started when Washington D.C. launched. So it was great. So we had these couple of cities, and then we went into France, and had to add some languages, but mostly, scale wasn't. People would come, how long is it going to take you to change the app to make it work in Paris? And I'm like, I'm Canadian, I'm French Canadian. I'll just throw some translations in there, no problem. So we were done in an afternoon. I looked like a hero. It was great. And then we went to the UK. Like, how long is it going to take you to the UK? I'm like, we speak English. We already do English. It's just another map. It's no big deal. I looked like even more of a hero. It was great. So started off really strong, and then things got straight bananas. Where this is a chart. I looked through a lot of kind of our company-wide summary emails to try to pick up all the times that we had launched countries and all of our counts of cities, and things quick. I mean, now we're over 200, right? So obviously, this sort of me looking like a hero like this couldn't last forever. Before I go over to some of the things that really stopped us dead in our tracks, I think it's really important to talk about the framework in which we operate, right? So for mobile things at Uber, first of all, our cities are all startups, right? So every single one of them is an empowered team that's fully responsible for their own cities, right? They decide the product offerings, they work through the pricing, they handle their own support, and they handle their own not only rider support, but driver support as well. So every time, if you are in, there's a Zurich, Zurich's a bad example. Actually, Zurich's a really good example, because if you email support in Zurich, in Switzerland, you've got people speak German, people speak French, and people speak English. If you email in, you'll get answered by a real person in that language, right? So this was very accidental, but I'm glad I picked them. So again, fully empowered teams. And what's interesting about taking these teams and just telling them to run and encouraging them to be innovative is, fortunately or unfortunately, they innovate. And these folks innovated big. And it started off real fun. We did a lot of on-demand events, on-demand crazy things. The first one was Austin barbecue. It was quick, took us a couple days to throw together. It was great. We ate stuffed our faces in barbecue. It was great. Then mariachi in San Francisco. I don't know if a few of you are kind of like old enough Uber users to have seen this, but that was fun. We did on-demand mariachis for Cinco de Mayo. That was great. And then we did La Fête de la Musique in Paris. So what's interesting is that these three came in about the period of 5 weeks, right? And we quickly realized that this was becoming 100% of my job. So I could no longer tell people, yeah, for this thing, it's going to take an afternoon. They just came in. As we expanded cities, it was really important that we shift our understanding of what this mobile app was into a tool for our cities teams. So here I've got a few examples of this. We've got when we did DeLoreans in San Francisco. That was really fun. I almost got run over by one on my bicycle. The one in the middle, that's on-demand lion dances that was in Shanghai, and that was for Chinese New Year. And then you've got everyone's favorite Uber kittens. I promised my team I'd have a lot of cats. And so again, this concept of like geo-deployment, downloadable artwork, dynamic style, all this was just, the app was just a shell to be able to deliver that city's content and their offerings in there. So really a change of every time that we had to build something, we had to keep this in mind, right? So this isn't one thing. We really have to be able to not slow down these cities. They have great ideas. We just have to let them keep going. then everything, then like a lot of these cities started getting really complicated. I put 3 here that are great examples: Berlin, Stockholm, and Milan. So again, seem like perfectly fine cities, not that much different than France or London. What we started, I don't know if anyone's tried to localize German. It's the word different, everything, especially the way that that nouns, verbs are put together. It meant that a lot of our we had to work with our copyright team, really having to be able to get them to understand how every time that we sent around localizations, we had to give a lot of context that were there. So this ended up slowing us down in our tracks. Regulation. A lot of European cities had really different ways of presenting price. What was really interesting is that a lot of these were much clearer than what we do in the US. We actually changed a lot of how we communicate things in the US based on these great concepts that we had found over there. But again, it just slowed us down. And then fraud. So fraud is a huge issue for us. We spend a lot of time. It's a cat and mouse game, right? So you're always trying to stay ahead of that. And we saw all kinds of different fraud come from our businesses in Europe. Now, personally, that wasn't a problem. Nothing is more satisfying than catching a fraudster, so I actually enjoyed that part. But it's great. And then every single thing got difficult after we started expanding past those cities. And this is where we really had to rethink how we were doing mobile development at Uber, because things just got so local that became difficult. I'll give you a few examples. India, China, and Panama. I'm sure a lot of you have dealt with this. In China, there is no Google. So you've got no Google Play services, and you've got no Google Play. So if I start with Google Play, that's something that's not too difficult to deal with. There's a whole array of Chinese app stores. You just deploy to them. They're complicated to use, but you wrestle through it and you do it. But no Google Play services, that's difficult, right? Because all of a sudden you don't have access to maps, which is part of Google Play services. So again, we had to find different people to adapt what we were doing. We were also doing something very specific to one country, which is something that we didn't want to do in the past, but what we had to shift. We'd always had this concept where if you're developing a feature, you should be able to develop so everyone can use it, right? But really now we had to come up with very particular technologies for very particular countries, and this was really difficult to do. Payments is a great example. Credit card adoption is actually low internationally, which is something that being in the U.S., living here, working here, buying coffee here for way too much is, you see that. But when you travel abroad, you get a lot of countries that they don't use that. Different merchants, a lot of prepay, and a lot of cash operations. So Alipay in China we were the first mobile app to integrate Alipay, which is a Chinese online payment provider, into our app. So really proud about that. But again, all this work, we had to dive into one country. This is where things kind of get fun. In Panama, I get a call from our Panama team one day. Got a laser pointer. Perfect. All right. So they started telling me that their drivers were ending up in the ocean, and others were telling me all over the place. It was bananas. And we dug in, and we found this right here, just as an example, Isla Chapilla. It doesn't exist on a map. It's this. You just have this giant block. What else is really interesting is that all this coastline right here is off by about 350 meters. So again, I'm Canadian. I don't know what your feet is, but that's quite a distance. And if you've got a car there, he's going to get really, really lost. So again, we ended up on our own. So we had to deal with some of these things. These things we're still dealing with. Actually, Google is they fixed this. If you go back today, based on a lot of our reports, they've actually fixed their coastline now, which is great. And now one of the most difficult things that we've had to solve for we have this fixed today in our app. People who have dealt with mapping technology in China have seen that there's a lot of locations that are obfuscated. And here's a great example. This is the border between Shenzhen and Hong Kong. So Hong Kong is not part of mainland China. It's its own entity, but part of China. And because of that, right here you see that in the Tongue River, there's this river that comes out of it. But as soon as you cross the border between, so this is Google Earth right here. This is Google Maps, and you look at so this one never lies. This one sometimes lies. When you right here, you see as soon as you get past the border of Hong Kong, the river is about 250 meters off, right? So that was really fun to deal with. So all these things as we went in. So we really had to be able to scale to make sure that this concept that we had of we're going to build tools for every cities, it just didn't scale. So number one, and this is fun. We had a lot of your previous presenters talked about this. First off, you had to grow the team. So this is a picture I took of our team working on the feature where in the app you've got the cars that follow the roads, right? So as they see that they traverse and they stick on the roads and they turn around. That was something that was really important to us. And this is our entire mobile team. What's interesting about our entire mobile team is that not only are they there, but we've also got our entire design team, that guy right there. And we also have our data scientist assumed for app visualization. That's right there. So really, our only mobile people were myself taking this photo, Chris, this guy right here, and Jordan you see hanging out behind there. So it wasn't working. I mean, we were spending all of our times on this expansion. So you've heard some of your previous talk about this. Yeah, scaling the team was just so important. So a lot of hiring, a lot of mentoring, starting classes, making sure that anyone at Uber could contribute to Uber. So making sure that we expanded our build products so that we could go in and allow these people to come in. What was really fun is that, as we found out that, a lot of people in Silicon Valley are doing really interesting things. Everyone on the team felt that we were doing it too. So going out and just telling people about, low-cost transportation, really good jobs for our drivers, and being able to build a product that was safe and all this. We were able to bring in quite a few people and train a lot others. And now, we've got just a ton of people contributing to the code base, which is great. Well, actually, it started off being great. Where it gets a little bit, when you've got one team, there's a lot of coordination of having to figure out what projects people are working on. So here's the cat pictures I was promising. So at Uber today, we have 17 product verticals. And it was really important that instead of all of us sitting together, we kind of decentralized the concept of mobile. So every single product vertical had its own mobile people in the team. That really helped them just move really fast. But you end up with all the opposite problems that happens when you try to do that, which is we were separated. People were coming up with their own solutions to the same problems. So after that happened, we really doubled down on trying to make sure that we had a really good community. So a lot of meetings, I say meetings, but like going to breakfast, having talks about what technologies we would import, making sure that as we were having a really, really good chat group where a lot of people were able to dump ideas on there, going to a lot of talks like this together, just to make sure that even though we weren't sitting together, even though we weren't actively working every day, we kept sort of our eye on the prize and all kind of sprinting in the same direction. The second, again, these are themes that you guys are seeing throughout the day, the build train. This was huge for us. So a lot of people who have shipped code for iOS know the problems that comes up when you're dealing with app review, right? So if you look here, as we started having a lot of contributors to the system, it was just we were just shipping apps as soon as they were being reviewed. Boom, new app in the store, bam, new app in the store. It was going crazy, and that's really, really difficult to scale, right? So instead, if you look here, back in the last sort of 3 quarters, we've sort of we've came up with a weekly cadence. And with that, we're essentially shipping about the theoretical max that you can get, which is 12 releases in a quarter, which is where we aim. These 2 lines, why they're not to 12, and this one is all because of rejections from the store. So pretty normal when you've got an aggressive company trying to get a lot of product out there. So it's great. So we're hitting that. And the good thing is, as people were, you could always count on another release coming in the next day, coming in the next week, coming in the next week. So that was great. It really helped people plan. Next, this one a little controversial. As we did that, it was really important. You've got builds going out every single week. So it's important to make sure that as people go out, they keep that mentality of you keep needing to move fast, right? But you have to, one thing that we really try to do at Uber is think of speed and quality as something that we need to innovate on as well, right? So how do you shouldn't be optimizing for one, you really have to be innovating in both. And one of what really helped us that is coming up with a concept of monitoring is at least as important as testing. Not that testing isn't important, but monitoring is definitely as important. When something goes out there, especially with that many folks contributing to your code base, there's going to be things that they don't expect. So it's important to make sure when it goes out there. I looked so hard to try to find a cat picture that was like at a control center. I apologize for not being able to find one. When you do this, great things happen, right? If you can actually manage this. And I wanted to look specifically in our last 6 weeks about what are things that we'd shipped that kind of took really big advantage, really huge advantages from this system. And Uber Pool, Uber Rush, Uber Fresh. These are products I'm such a huge fan of. This. Uber Pool, the concept of being able to lower prices but increase driver take home. is just great. The driver's just constantly on a trip. He's constantly, every single minute when he's driving, he's actually earning money, and customers are getting a lower cost. I mean, these are great. But again, they've got to innovate. Even though these are fully, very, very mobile heavy products, very front-end heavy products, we've got to come up with ideas where they can ship really often, they can iterate. And this concept of having a weekly release train really helped them out with that. Yeah, we're a young company. This is just the beginning. I'm really excited to see what this presentation looks like. Hopefully when I come back to do it next year. But yeah, so in 2012, hopefully we'll keep going with this. And there you go. Thank you. I'm Paul at Uber. If you guys have any questions, send me an email. Thank you.
So why don't Kieran and David come up, and we'll take Q&A for a good 5 minutes, and then let you guys take a break for a second. So any questions on any of the 3 topics?
Hey, how's it
Kieran.
going?
Nice to meet you.
Any questions? There we go.
So, sorry, the question is for, I forgot your name, sorry. It's about Buck. So how do you integrate Buck with testing tools? You talked a lot about speed up and the advantages and how to get over the 64K limit, but not about testing integration, so I'm curious about that.
So the 2 main types of tests that we do at Facebook are unit tests, on our Android code base, are unit tests with Roboelectric and automation testing where we run the app on a device or emulator and interact with it programmatically. For the unit tests, Buck does have built-in support for running JUnit tests, and I think there's a pull request out for TestNG, and it is able to integrate Roboelectric into those JUnit tests. So most of our tests are just run with Buck. You say Buck test, and it builds everything the way it always does. It runs the tests with JUnit and Roboelectric. I don't know as much about the emulator testing, but they do use Buck to run those. We don't support what they call instrumentation tests, where you just ship the APK to the device and run your instrumentation code. We can build those APKs, but Buck will not run those tests for you.
Hi, this is a question for Uber. Do you see any feedback from end users when you're releasing apps every week? Have you done any studies? Is it too soon? Is it just perfect? Obviously, a lot of users have auto updates, but for the ones who don't have.
Yeah, that's a great question. We see very little feedback. Most people are so excited about the new features that sort of gets kind of hidden away. In general, the auto update is what saves us, right? So, I mean, if that wasn't there, then I think people would see it. Also, the other thing that we've noticed, because we actually, we were concerned that would be an issue, but in general, people have so many updates that they push them. I think that the key to that for us was just being really, really transparent and clear. And if you look at our release notes, that's something that we take pretty seriously. We even localize them. So yeah, I think as long as you're careful with that and people know what you're doing, then yeah, we haven't had any problem with it. It's a great question.
Hi. So one of the things I'm hearing a lot throughout today is the people moving mobile from platform to product, and in so doing, not being able to hire enough people. So overlaying training programs instead of trying to hire everybody to accomplish that. I'm wondering if whoever of the 3 of you has experienced can elaborate on what the logistics of those training programs look like internally.
So I can talk about what we do at LinkedIn. So at LinkedIn, we did a training program. We used a company called Big Nerd Ranch, which I think actually Facebook had used at some point. It's a 1-week iOS training course, 1-week Android training course, and then we do a 2-week apprenticeship, which is pretty much they come and work on a feature or bug fix area, and they have somebody who's already part of the mobile team to sort of help them get in, sort of submit code, write tests, and get the thing out in the build. That's what we ended up doing. Then I think next year we're actually looking at building our own internal training program for that.
Facebook's pretty similar. We also have a number of courses that we developed internally that are for things specific to Facebook that are taught by the engineers, usually like an hour.
Yeah, Uber does all these things. So we've got courses, but at the end of the day, it really just is about, a lot of people need to contribute, right? They don't want to they're not going to spend their whole day at this. So we have a core team, and again, if depending on your product, they'd be easier or less easy to hire for. But it's just making sure that your core team is really aware of this, is really embracing it, and making sure that they're putting out really good wikis. They're participating in the training programs, which we do. I gave one just last week. We go through, making sure that you invest in making sure that your build tools are really easy to use. You want people to be able to just download stuff and just hit run and have it work really easily. What's really fun about Uber, what helped a lot, is that on people's first day, they get set up using the iOS simulator. So the iOS simulator has this fantastic feature in it, which gives you like a faked trip. Well, actually, it's a real trip, but it's built in a simulator from Cupertino up to San Francisco. So again, for us, that's really helpful because it's got built-in motion. So yeah, little ways to bring it in and just make sure everyone's really familiar with it. Yeah, which is helpful. It's a good question.
David, you had mentioned that ADB tops out at like 4 to 6 megabytes per second. Is it possible to speed up build times further using the network to transfer the files instead?
I haven't tried that. I think there's a lot of operational problems with that I don't want to spend time helping people debug their network connection, especially like wired to wireless.
Okay, so we're going to wrap up here. Let's give a round of applause for our awesome speakers. Great job, guys. Thank you. We're going to take about a 5-minute break. So we'll start just a hair after 3. Or what? Yep, 3. And I know people had other questions. You can ask them in the group. Again, everyone should join the group. All right, everyone. Let's take our seats. So our next speaker is from Microsoft. His name is Igor Zyka. And he's going to talk about Microsoft's approach to cross-platform development on Office. So without further ado, here is Igor.
Okay. Hello. Okay, you can see my slides, so that's fantastic. So hello, everyone. My name is Igor Zyka. So Kevin did an excellent job of pronouncing my name. So I came from Siberia, where it's very cold, much colder than in San Francisco. So I'm happy to be here for that reason as well. So I moved out from Siberia quite a while ago. So when I've got an invite from Facebook folks to come and talk here, I was actually interested in whether my talk and the things that I'm going to talk about are going to resonate with mobile developers, because if you think about Microsoft and specifically think about Office, it seems to be the opposite of what everyone has talked about today. But as I was listening through some of the talks today, I was actually surprised how we come to this from a completely different direction, because we are obviously not a startup by any measure. We have huge product, and I'll show you some of the statistics about our product. It's a big code base. And it's a very old code base as well. But we are coming to the same conclusions. We are using some of the same approaches. So here are the topics that I'm going to go through today. So first, I'm going to actually give you a brief history of Office, because some of you might be familiar with that, but some might not. And don't worry, it's not going to take a lot of time. And actually, the thing that I found surprising while preparing this is just how much of this history resonates with modern mobile development. A lot of the mistakes that we've made, a lot of the solutions that we found over those 30 years are completely 100% relevant. They're actually exactly what those talks today were about. So we'll go through that, and hopefully you're going to be as surprised and fascinated as I am. And then the next thing I'm going to talk about actually the state of the ecosystem, why Office is doing mobile, for example. None of that is going to be surprising, but the thing that is interesting is to look at all of the individual influencing factors that affect those ecosystems, and more specifically, all of the tensions that this generate. Because a lot of those factors are sort of self-contradictory and asking you to do two completely opposite things at the same time. And last, and I'll try to spend most of the time on this, is our actual technical strategy and what we do and how do we approach mobile development in Office. So brief history of Microsoft Office. It's 30 years old. It's actually just over 30 years old. So that's very old. Actually, there is a joke inside Office teams that our code base is old enough to buy its own alcohol and to have kids. In fact, most of the people, and I tried to do this calculation and didn't figure out how to get the data. Most of the people who work on a code base are younger than a code base. So most of the people were actually born after the first line was written. And the history looked like this. So it all started as individual apps in C, and we've actually lucked out that we've started in C and not anything else. And Microsoft Word for DOS has shipped at the end of 1983. And those two people were the key developers on Microsoft Word. So the guy on the left in the sunglasses, his name is Charles Simoni. I don't know whether you've heard about him or not, but he was one of the original developers of the Park Browser. And this was the first real WYSIWYG document editing system. So he left Xerox, he came to Microsoft. He was a dev manager for the Microsoft Word project. Another thing that is fascinating is that if you could read the letters on this screenshot, you would notice that Microsoft Word for DOS was developed on Unix. So I guess Charles Simoni liked Unix. And the last thing about him is that if you've ever heard about Hungarian notation, and you probably didn't, so that's a funny name, a way to name your variables that allows you to make non-type-safe C to be somewhat type-safe, and it leads to some interesting naming conventions in your code base. And then in 1995, Apple shipped Macintosh, and we've actually shipped Office applications on Macintosh. So we've started doing cross-platform development, not exactly mobile, it was desktop machines, but it was real cross-platform. There was very little similar between the DOS and Macintosh. So we've shipped that in 1985, and then came Windows. We've shipped on Windows as well. The thing that is fascinating when I was looking at this screenshot is Word 1.1 on a machine that had 1 megabyte of memory had half of this memory free after booting. And I wish our applications, even on mobile, were that small. So it's basically like roughly 256 for Windows, 256 for Word. And that was a full WYSIWYG editor with lots of bells and whistles. So 1990 was when Microsoft Office was born. So we've just bundled all of the applications together, called them Office. Virtually none of the code was shared between them. They were just individual apps with individual teams, but users loved it. So Office really started to pick up after that. So Office was successful in 1990. So what a lot of people, not all of them, but what a lot of teams do when they build a new product, it's been successful for a while in the market for 3 or 4 years, starting to dominate the marketplace, what do people do? So sometimes people decide that they need to rewrite everything because of course we've now been building it for a while. We are extremely smart, we are extremely successful. We are going to rewrite everything. It's going to be well architected because we know all of the faults with an existing system. It's going to have common code base. So that's actually interesting because a lot of that is going to resonate with the rest of the talk that can target Windows and Mac, because we were starting to get tired with building multiple versions of the apps for Mac and Windows. And we went and actually did a lot of work for a fairly long period of time, more than a year. And what usually happens when you do that? Well, we've started to use C++ as well. But what happens is that usually projects like that do not succeed. We went for a while and we realized that what happens when you have a successful product and you try to rewrite it without really thinking about it too much, even with the best intentions, you forget all of the good things that the code base did and all of the good things that your users loved. So project was canceled. We had some really smart managers, but we did salvage a few things. So we've salvaged some of the architecture. We've actually managed to build a different product that could dual target to Windows and Mac. It was called Microsoft Word 6.0. And those charts, very old charts, so that's market share of different WYSIWYG processors, Word processors. So I don't know whether you've seen it, but basically Word 6.0 ended the competition. So not all of the other products died after that, but it really became dominant. It was an awesome product. It was very functional. It was fast. Users loved it. So we've dual targeted Mac and Windows. How did Mac Word 6 do? From the same code base, it didn't do nearly as well. Users did not actually like the fact that the product looked like Windows app running on Mac because we're so successful with making the same code run on both of the OSs. Actually, the performance was significantly worse. And when we were shipping it, it was already not a surprise for us, but it was probably a surprise for a lot of people. And it had a lot of reliability problems on a Mac that did not exist on Windows. So I'll actually go into details of this when I'll talk about some of the choices that we are making now based on some of those decisions. Lots of other things happened to your code base. Windows NT, Windows 95, we've moved to 32-bit, we've moved to Unicode. As you can imagine, for editing applications, both of those changes in the ecosystem were huge. They required significant redesign. Office 97 was a big release for us. We've made apps actually share code, because if you have apps that have toolbars and menus and dialogues, and you're using different technologies to do that, you're probably doing something wrong. So we've started to do this. We've started to use C++ at roughly the same time. It was C++ 98, so the Dropbox presentation had some of the types of code that we were writing. Actually, a lot of the code was still C compiled as C++. We added COM, we added Visual Basic, lots of different features. And then there was an innovation of the teams that I am on right now called Core Experience. We own most of the common user interface components in Office and the low-level application frameworks that they build this feature. We thought that it's going to completely revolutionize everything. So we talk about building features without really understanding the users first. But the quote actually says, "I see you are trying to take over the world. Can I help?" So other things help. This didn't necessarily do that. One notable thing that did not happen with Office 97 is we did not ship Office 97 for Mac. And the reason why we did not do that is we were so embarrassed by our 6.0 experience that we've decided that we're just not going to do the same thing. We are not going to have a code base where everything is so perfectly portable everywhere that it sucks in its own way. So what we've done instead is we've actually created a separate team that was completely focused on Mac. Part of this team is in Silicon Valley, part of this team in Redmond. So this team has complete freedom to optimize for Mac, both for performance and for Mac-appropriate user experience and application features. The product was called Mac Office 98. It was very successful. It actually, we've gained back some of the lost trust with our users. This product was important for Apple as well, because in 98, Apple did not do as well as it does right now. So it was actually very important that we've shipped for them, that we've shipped this product. But we've lost some things as well, because we've sort of over-indexed in a separate direction. We went from we can run everything from a single code base, from the single branch. Every developer actually had Mac and Windows machine. So we went into another extreme where we've shipped an excellent product, but we've lost a lot of the code sharing. And again, I'll talk later on what we are doing with that. So a lot of other things have happened. We added more apps. We added Visio, OneNote, Project, many other apps. Mac code base went through many different tool chains, GCC, Clang. We've redone our UI. We've decided that menus and toolbars and dialogues is too confusing to our users given the complexity of the apps. We now use ribbons and side panes and dialogues because we had so many, it was difficult to get rid of them. And we've shipped Office for the web, so actual HTML apps that you can use in a browser. And we are on a version of 14 of the VC compiler by now. And we've killed Clippy. So that was innovation of the decade, #2 with a single feature. So that was a lucky coincidence for us. So actually the email that went out when this change was checked in was amazing. What are we doing now? So the things that we are doing now is we have just shipped Office for iPad. I don't know whether you know that or not. It's a real Office product. It's actually using a lot of the code that goes into Win32 product. It's been very successful for us, and it was out for just over 3 months. We have, I think, 35 million downloads or something like that. And it was very well received, so users loved the quality of the experience. We've moved to modern C++, although the better description is we are moving to the modern C++ because we couldn't find a switch to just move our code base to the C++ 14. So we're just slowly going through this transition, but we are very determined because there are a lot of features that we actually like. And we are working on versions of Office for Android and WinRT, and I'll talk about some of the approaches that we are using for that. So how is this relevant to at scale? So it might already be apparent, it will become apparent later in the presentation, but a lot of the lessons that we've learned about cross-platform actually directly applies to what's going on with mobile right now. So we are going from a different direction. We have a huge product that was cross-platform in different ways for quite a long time. We have made some mistakes. It sounds like a lot of the mobile companies have made similar mistakes. We've learned things. It sounds like a lot of the mobile companies are learning those things now. And we need to be on a mobile. We need to be where our users are. So some of the things that we've learned from the history is that despite the fact that we've been doing as an industry cross-platform for quite a while, it's still hard. Not sharing code is bad. Sharing too much code, just as bad or even worse. Platform landscape is always changing, so something new comes up, something happens. So iOS was dominant, now Android is dominant. Who knows what is going to happen between those platforms? Platforms themselves evolve, so don't assume that things are static. And C and C++ actually worked out really well for us. And that's, for me, one of the more important takeaways looking back at the history. When I think back at what other language could we use that had the same combination of longevity, but at the same time evolution, I just don't know what that language would have been. Almost any choice that I can think of would have either been reinvented 1, 2, or 3 times, requiring us to rewrite everything, or would have been abandoned, requiring us to rewrite everything for a completely different reason. So it's an engineering conference. I'll actually show you some code before I go to more diagrams. So don't try to read it. I know that the font is too small, but the function on the left is actually a core editing function from Microsoft Word. It's taken from the version of the code from 1989. And the interesting thing about this function is, like, remember the Facebook presentation about immutable components and one-way notifications? That's how Charles Simonyi designed Word from the start. So Word is actually based on immutable. The Word document is an immutable data structure. We actually never modify the character stream or all of the formatting. So all of the edits are done on top of this as revision changes. It cannot be objects because some of the objects will be too complex to update. So this code existed there from almost very beginning, so it injects something in the middle. On the right, the same function in Word right now. I actually took it out of the code base like a week ago. And the highlights is green is basically the same code. So we like this design. It's awesome design. It looks like a lot of people like similar design now. So we've been able to keep it because C++ survived all of this time. But on the other hand, if you look at all of the blue things, those things are very important as well. So the language used to be not type safe, so that's horrible. So now language is type safe, so we've changed that. We used to like global variables, so I'm not actually quite sure how Charles could be that smart about some of the design decisions, but still use global. Well, actually, I know exactly. The performance was so important that people were willing to sacrifice some of the niceties of the code for the performance sake. So we no longer do that, so we don't use global, so that's another blue. And security just wasn't as much of a concern back then. Now it is extremely important for us because we are an attack vector. So type safety, better componentization and structure of the code, and security. So this is really the only difference. So all of the good things we could keep, and all of the things that had to be evolved, actually the industry and us will manage to evolve. So I'll spend just a little bit of time talking about why we are talking about mobile, and that would sound very familiar given the presentations before. First of all, if you look around the room, everyone is using 2 or 3 devices. So that's just the reality of the world. It's just no longer a few people using mobile devices. Everyone is using a number of different devices. Those devices run different platforms, and that's the reality of the industry landscape. So we have to be where our users are. We have to be on Windows, on Apple, on Android, on the web, because if we don't, then we are not going to have sustainable business. Content fidelity is extremely important for us. So if you think about what Office is about your ability to author a document on one device, on one platform, and being able to display it perfectly on any other devices, and being able to edit it without ever corrupting your data. And we are looking for a market-leading experience. So we don't just want to be on all of those platforms. We actually want to be the best productivity apps on iOS. We want to be the best productivity apps on Android, and we want to be the best productivity apps on Windows. And that actually affects our choices in a very significant way. And we need to increase our velocity of innovation, because Office was always good at shipping on time, but we were good at shipping on time every 2 years, which is just not nearly fast enough in the modern world. Like 2 years, some of those companies that talked about amazing products today were created 2 or less years ago. So some of the influencing factors. So obviously there is Windows, Apple, Android, web. For a lot of the people in Europe, Apple and Android are probably the most important one, but web is pretty important as well. Windows has desktop. Each one of those guys have different APIs. So Microsoft has Win32 and WinRT. Apple has iOS and OS X. They're pretty similar, but not exactly similar. But then, somewhat orthogonal to that, there is a question of form factor, because you have phone that has one set of constraints of interaction. You have tablet, and then you have desktop, and then there are large screen, and then there is Apple Watch. So what if I wanted to project from a watch? Actually, wouldn't be that crazy of a scenario if you could make it work, but I'll probably not interact with it the same way I interact with tablet or even the phone. Different modalities of interaction as well: mouse and keyboard, touch, voice, gestures, compute. We used to do everything on the client. Now we do a lot of things in the cloud. There is much wider range of capabilities of devices because computers used to be very similar. Now they're extremely diverse. So those are influencing factor, and you can see that a lot of them just contradict each other. So they push you in different directions. So some of those tensions is you want to share code, but at the same time you want to have rich experience, and you cannot affect least common denominator. So you have to proactively fight that, because that's where any code sharing is going to push you, no matter how many times you're going to say, I will use native UI framework. Platform integration. You always want to use the latest and greatest features on the platforms. That's just how it works, because that's what everyone is going to talk about. That's where users are going to go. So you need a very low-cost approach for how you can use platform-specific functionalities that just came out, and it cannot be expensive. But on the other hand, you need consistency of functionality. So when you differentiate between different platforms, you always take a risk that one platform is going to be significantly different from another. For Office, given our document-centric model, the complexity is that if we build features that actually go into content that are only available on one platform, users are not going to use it. We've tried it in a few places, and it just doesn't work. Unless it's present everywhere, you might as well not build a feature. Consistency of experience. So we need to make sure that our documents look completely perfect, and that all of the interaction with our servers are consistent as well between all of the platforms. And sometimes what it means for us is that we actually need to become OS developers. We need to take bits and pieces of OS code. For example, rendering is very important for us. So it might not be a crazy thing to say that we are going to just port all of the lower-level rendering code on all of the different platforms. And apps need to be consistent between themselves as well. So we want PowerPoint on iOS to clearly look like an iOS app. We want it to look like a Windows app on Windows. But at the same time, when users use PowerPoint on any of the devices, they have to understand that this is PowerPoint and not some other app. And release time and velocity of innovation is very important, because if you take too long between your releases, you're always going to have functional skew, and that's just not acceptable. So what is the solution? So we are here to talk about different solutions. So we've actually tried to put this question into all of the search engines that we know about. What would be an awesome, clean, architecturally sound solution for taking tens of millions of lines of code across several large apps that have been written over 30 years, supporting more than 1 billion users out there in the wild, and put them on multiple platforms and form factors, all with different API sets, and do that in a sound engineering way? And the answer was that, well, actually no one knows, and in fact we don't know either. But a few things that we do know is that there is no silver bullet solution. So there is no magic way to make this happen. We've tried a few different ones. They don't work. But there are approaches. If you understand your trade-offs and cost, risk, benefit trade-offs, then you can actually do quite well. And I'm going to talk about that in more detail in the rest of the presentation. So our cross-platform technical strategies. So what do we actually do? So yes, we start from a different from a different site. We already have a large code base, been on many different platforms before. Now we need to make sure that it's on all of the mobile devices, on all of the mobile form factors, on all of the platforms. How do we do that? Very difficult to describe all of the different dimensions that are involved in that. So instead of that, I'm just going to focus on 3 things. So one is working in a large code base, and we don't like to call it legacy. We actually like to call it legacy rich. And I'll show you one example on how, if you use proper engineering approaches, you can actually make legacy code base to work with you, not against you. And we believe that our applications have been very valuable for users for a long time, and if we do this work right, they will continue to be very valuable for the users on the new mobile devices. So second thing that I'm going to talk about is design and platform abstraction layers. So that's how you put boundaries between your shared C++ code and platform-specific functionalities, and what to do, what not to do. And then I'm going to talk about shading or not UX code and different trade-offs there. So So that was actually a test. So I just want to test whether anyone knows why I was showing this video. So I actually didn't even want to show this video. Instead of that, I wanted to show a completely different video. I wanted to show a video of an airplane that is getting rebuilt while it's flying, because it would have been a much better analogy of what we have to do. And actually, a lot of the people in the mobile community need to do as they evolve their apps. Because the things that we have is that we have a very complex code base. Even relatively new companies that grow very fast have very complex code base very quickly, and we just cannot stop the train and make big architectural changes, or, for example, put our applications on other platforms by stopping for a long period of time and then building something completely new and replacing it. We have to do something like in this video of a highway overpass getting replaced in Bellevue, Washington, where they very carefully constructed a new span of a bridge on a site without blocking any of the traffic. And then when it was ready, and they've tested, I hope that it was ready, they've blocked the traffic for a very short period of time and just added this new bridge span to already existing bridge. And they had a new, much wider bridge, much better designed, excellent seismic qualities, without actually stopping traffic for any significant point in time. So we have to do something very similar with our code bases. And when I say complex, like, it's always interesting to figure out how do you show complexity. And we've already seen some diagrams, I think, from Facebook with different arrows. So that's my arrow diagram. So again, I understand that no one is going to be able to read it, but what you see is actually the dependency graph of all of the build units that go into Microsoft Word. And this doesn't even include all of the shared code. So that's just a Word app. And it's not even interfaces and components. It's just an individual set of buildable components that are getting put together. And you might look at this and say that, okay, so clearly you guys are just not smart enough to build something simple and well-designed. So the thing that I would say is that, okay, so maybe half of that we were not smart to build something well-designed, but that's just the reality of complex software that has a lot of usage. So we need to know how to rebuild an airplane while flying. Otherwise, we're just not going to succeed. So how do we do that? So there isn't actually an agreement even inside Office on the best way to do that. Actually, a lot of people would advocate that we should do roughly what we've done with Mac Office 98, where we would just fork the code. So we have excellent source control system. So we'll just create a branch and we'll put a dedicated team into this branch and they will go off. And we actually have a proof that they're probably going to release an excellent product and it's probably can happen fast. And you know what you're getting. You know that you're going to have a team that is going to be single-minded. They are going to be focused on this product. They are going to be able to iterate fast. You know that they're going to be isolated from your main product. So you know that they are not going to break your Windows product or your Mac product in our case. But on the other hand, we know what happens because we have this 30-year-old history, because we know that it's only going to be fun for first couple of years. And then the third year is going to be a little bit less fun because you would realize that in order to merge in, pull in all of the changes that happened in the main trunk, you're now going to spend significant part of your engineering course just doing that. So we've decided that we're just not going to repeat that. We want to learn how to do everything in place. And the way we've approached that is we said that, well, the only way to do it in place is we actually need to figure out how to componentize our code base and build a set of components that can be composable with each other, so that we can reason over like what components should go into each platform-specific version of the app. So when we started to do that, we relied on a lot of the mechanical refactoring. And that's actually one place where C++ worked against us. Because C++ still is relatively weak when it comes to code analysis and refactoring tools. Inside Microsoft, we have a lot of tools that actually can do excellent code analysis, but they're all geared towards security. Because security is such a big priority for us that we've actually built all of this infrastructure. But we've never invested enough into making refactoring tools work really well for C++. We are super excited about what's going on with CLang and some of the tools that are now starting to come out. Places where we couldn't do mechanical refactoring, we heavily rely on unit tests. And I wish I could say that everything in Office is unit tested. I cannot say that. We do have a lot of code coverage. If you look at our code coverage for a legacy code base, it's very, very high, especially if you exclude all of the features at the periphery, because we have a lot of breadth, and then we have core that is highly used. Core that is highly used is actually has high degree of automation coverage, but not unit tests. And when you start building components, you absolutely need to do that. I'm probably preaching to the choir. But then we've done a couple of other interesting things that had big influence on how developers behaved. One is that we said that we are not going to allow pound ifdef. So we just cannot do things like ifdef iOS, ifdef Android. You just don't do that in any of the code. And we do not allow any of the runtime checks. So you cannot do if iOS do this, if Windows do that, if Android do that. Because if you do this, you do not have portable code. So the amount of combinatorial complexity that you're going to have inside your code base is going to be so bad that you might actually be better off just having separate versions of the code. And we kept everything working at all times on all platforms. So Windows version, WinRT version, Android version, iOS version, all of them have to work at all times. Zero tolerance for any regressions of any automation, and zero tolerance of regressions of functionality. And we ensure this by doing very broad dog food. Microsoft is a big company. That's the advantage of a big company. You can actually just push software to all of the people. When you have this many people, you actually get quite a bit of usage by just doing that. This is the place where the legacy code base actually turned out to be an advantage, because when we started to do this, developers actually complained that it slows them down. They have to do too much work. They have to componentize, write unit tests. They need to do this and they need to do that. In reality, what it meant is that when they were doing work, they had to figure out all of the integration complexity up front. And that actually gave them all of the information that they need to do proper design and proper implementation. And it really played out well for us. So next slide, and next 2 minutes, we'll explain everything about the actual architecture that we use. So in a very gross oversimplification, this box in the middle is Office. And it consists of a few pieces. So the big box in the middle is all of the shared code. It's all C++, so no other language is used there because we just don't know of any other language that can be cross-compiled to all of the other platforms. Another reason why we try to keep this box as big as possible is content fidelity. The easiest way to have content fidelity everywhere is just use the same code to read, layout, render, do editing operations on all of the platforms. It's difficult because of the differences between the platforms, but if you achieve that, you know that you're never going to corrupt your documents, and that's a very important thing for us. So on top of that, we have service code. And again, you would think that Office is just a client application, but we actually do a lot of things in the cloud, not just with web apps, but with a lot of the collaboration scenarios. And we intend to push as much of the functionality into a service. We have to learn a lot about how to do this properly, but we already started to do that. We are going to do more, but we'll only do that where there is no expectation that the feature should work offline, because we are primarily an offline product. We believe that this is actually a big advantage. I can present in a room that sometimes has poor connectivity. Actually, I didn't even try to check what connectivity is because I was listening to the presentation. So on top of the big box of shared code, there is native UX. We actually just use native UI platform. There were a lot of discussions on, like, do you use HTML5 or do you use some intermediate layers or some custom UI frameworks? So I'll go into that in a little bit more detail, but we are firm believers that you need to use native UI frameworks. That's the only way to deliver best performance and best experience for users on a platform. But you need to keep this layer very narrow, and a lot of effort goes into that. And then at the bottom, there is a set of platform abstraction layers. So functionality in the OS that is different between different OSs, you need to abstract that. The fact that there is plural is actually very important. So we don't build one abstraction layer, we build multiple targeted abstraction layers. Often when you build features in a system like this, you need to work in all of the layers, and sometimes it's a downside, but we're just accepting that developers need to understand how to work in service, how to work in UI, how to work in shared. And it actually makes people learn more about the overall architecture of the product. So I think that the easiest way to talk about how successful we were with our approach is to look at the code sharing statistics. And those slides are actually from the PowerPoint architectural review 2 weeks ago. If you look at the WinRT version of the application, 96% of the code is shared code. So it's lines of code that identical lines compiled for WinRT, Android, Win32. So only 4% are unique. And those 4% are basically XAML files, because we build WinRT UI using XAML and UI-specific C++ code. If you exclude XAML, it's actually 98.6%. If you look at Android, 95% is shared, 5% is Java. And actually, when we looked at why it's higher than for Windows, we've learned a few things with our code gen tools that we generate for UI, where we generate code for UI bindings, where we just generate too much code. We think that we can make it even better. Again, it's cool if PowerPoint is just, I don't know, 1,000 lines of code. That wouldn't be interesting. It's actually tens of millions lines of code if you count code across all of the applications. That's why we care about those like 1% difference, because it makes a huge difference in engineering cost. So I'll jump into platform abstraction layer. So lots of history in the industry of how you do write once, run everywhere solutions. So Java, Flash, Silverlight, Pcode, HTML, 2 approaches push level of abstraction very low, so that you can just write a lot of code using the really low level APIs. Like if you can compile to something like machine code, even better. Or you make your API very broad, so that you can just live in this world. And we've actually done some of this. And we've hit a lot of the impedance mismatch. And impedance mismatch is an electrical engineering term, but it works amazingly well for software. And the best way to describe it is to actually describe what is impedance matching. Impedance matching is the practice of designing input impedance of the electrical load or output impedance of the corresponding signal to maximize power transfer or minimize signal reflection. And what it means for software specifically is that if you have a component that talks to an OS API and it pushes too much data to it, or makes calls too frequently, or uses it in a too complicated way, two things happen. Is either you blow up, so you don't have performance, you don't have the functionality or polish you need, or the OS blow up, and both of those are really bad. And actually, the Vert6 story is exactly that, because the Vert6 was just built on top of Win32 emulator. The people who've done this were extremely proud. So they thought that they've achieved amazing engineering feats by building this Win32 emulator, but they've hit all of the impedance mismatch problems. So user experience looked like Windows on Mac. Performance expectation mismatches are incredibly hard to deal with, because if you make very frequent call to OS APIs, even small differences in performance aggregate and make your application suck. And you cannot interop with any of the native UI. For example, if all of the UI is built using your own UI framework, you cannot embed any of the OS UI in yourself or yourself into the OS API. And you hit the least common denominator effect, because when developers find bugs that only repro on one platform, their first reaction is to actually limit the functionality so that they can avoid this bug by not doing something, because it's so difficult to get around them. So actual quotes from the Vert6 developers, there is actually a blog post on this that was published about 10 years ago. The only good thing about beating your head against the wall is that it feels good when you stop. This is direct reference to Vert6 experience. But when you do that, you actually learn how to do it a little bit better. And what we now do with platform abstraction layers is we only build them where we understand what our application needs to do. And it's amazing. Every time we do that, you think you understand your code base. Before you've done that, you don't. And we do not accept least common denominator. So we really need to understand how this is going to work on all of the platforms. And we are willing to sacrifice code sharing, and we are willing to redesign shared code in order to achieve better matching of the APIs. So the specific example of what we've done using this approach is composition and animation. So our documents are highly sophisticated custom rendering documents where we overlap a lot of objects with different effects. Everything can be animated. Obviously, it's editor, so everything is interactive. And with touch specifically, a lot of the touch interaction is basically real-time input and animations attached to it. So it's super critical for us that we do it really well. Very common solution to that, and we've actually done that on Windows, on Win32, on Windows 7 ourselves, is you just build all of that on top of OpenGL and DirectX. Those are very powerful APIs. You can do that. That's what OSs do anyway. So you just go and do everything ourselves. We had to do this on Windows 7 because it doesn't have a compositor API. So we've built all of this infrastructure. And what we found is that even on one platform, that's just so incredibly hard because you rely on different GPUs, different video drivers to have the right performance characteristics and the right reliability. And when something is as complex as OpenGL or DirectX, it's just very difficult to do that. Imagining that we'll be able to do that on iOS, so it wasn't possible to imagine that. So what we have done instead is we actually took people who built all of this. So it was very important that those were the same people because they finally learned what we do. Because before we've done this work on Windows, we really did not understand how our applications work. And we've made them go and research core animation, research Android, and basically become deep experts on how composition, animations, touch interaction work on those. And we've learned a couple of things that are actually very common in other places as well. First is that people don't live in a vacuum. A lot of the subsystems in operating system are influenced by the same design trade-offs, so there were a lot of similarities. And we could actually see how we can build a set of interfaces that allow all of the compositing functionality. But we've as well learned that all of the OSs have performance and threading constraints that were completely opposite. So what core animation likes to do on the UI thread, you just won't be able to do on Android because it already does so much on UI threads that if you do anything else at all, you're completely screwed. So you have to figure out how to do everything on another thread. And obviously on Win32 there is no animation and composition libraries at all. So what we've done is we've said, okay, so we're just going to go and design an API that abstracts this out by making this API consist of async non-blocking APIs where we can reverse threading semantics in a way that is going to match all of the platform. And if you look at the diagram of how we actually composite all of our documents, so on the left is a big shaded block of C++ code, loads documents, does layout, and does rendering. On the right is our API that is completely shared. We use the same API on all of the other platforms to construct all of the layers and set up animations. And then there is a set of channels that go to different backends, and backends are different on different APIs. So custom backend on Win32, we use XAML on WinRT, we use core animation on iOS and OS X, and we use Android views on Android. But the most interesting thing is that if you look at the threading structure, so the green box is UI thread. The white box is what we call application thread. So actually, it's multiple threads. That's where most of the app runs. And the compositor thread, application and UI thread are inversed on many of the platforms. So on Win32, we do everything on UI thread because that's just how Win32 apps work. On iOS, we do that because you can get away with that with core animation. It's a good API. And then on Android, we actually do everything on a background thread. And because we've used this async non-blocking API, we can completely reverse it, and all of the code would work. And if you go and play with our iOS APIs, with our iOS applications, you would actually see that the quality of experience is really awesome. We actually managed to nail our touch responsiveness and the quality of the experience goals. So those apps are actually really, really good. With XAML, we've used Android approach, not because XAML has the same problems as Android. It actually is better, but because we've already figured it out how to do this, it's just better to not do anything on a UI thread, because this way we can guarantee 60 GHz response. So I don't actually have time to talk about what we do with UI, but I'll just very quickly say that what we do is a combination of what Dropbox does and Facebook does. So you guys are smart. So that's the way to do it. So basically, what we do is we have an internal IDL that we use to define all of the components, and even the words are similar in some cases. And those components are fundamentally immutable components. So we use a subset of types that we can project into Java, that we can project in XAML, that we can project in into Objective-C. So the reason why I said that it's sort of a combination of it is it's both the boundary layer and it's the same mechanisms that we've used for view models and models. And that's how we achieve the amount of the code sharing that you've seen. And to close, what I'll say is that really the most important thing is no silver bullets. Like if somebody comes to you and tells you that they have this wonderful technology, just use it and your mobile app is going to be awesome. Some messiah will show up at some point, but I doubt it's going to happen in the next 10 or 20 years. So really make sure that you understand all of the trade-offs and cost benefits and risks. Shared C++ core worked awesome for us, seemed to be working for everyone else. C++ 11 and C++ 14 is a much better language, and actually there are relatively few downsides compared to other languages. So that worked well for us. I think it can work well for a lot of people. Use native UI frameworks. That's the way to achieve quality. If you design your app smart, the amount of code you actually need to write is very small. And like at the bottom, really think through the performance characteristic of your abstraction layers. Don't just try to build something like Win32 emulation, or like people have tried to build so many of those. I won't just be able to name them in 10 minutes. So that's the end of my talk. Thank you.
All right. Thank you, Igor. We actually don't have time for a Q&A, but we'll be back here at 4 o'clock sharp for our last and final talk on emerging Android. It's actually super awesome. So, I think we might have actually saved the best for last. But let's thank Igor again. I'm sure he's available for questions after the talk and at the happy hour.
Yep.
Maybe you'll get
I'll
more
be
frank
around, so
answers
if you
there,
have questions, stop by. I'll tell you more stories.
Thank you, Igor. All right. Home stretch, one final talk, and then we go to happy hour. Yay. So for the final talk, we're going to talk about Android. And it's a really important topic as I was talking about in the keynote. And we have some people from Facebook here to talk about it. So we have Chris Mara. We have Tyler Keefe from the Instagram team, actually, and Andrew Rogers. So without further ado, I'll hand it off to Chris, who's going to frame up the issue and give you a ton of information on the Android markets. It's super interesting.
Cool. Hey everyone, my name is Chris Mara, and I'm a product manager on Android at Facebook. And as Jay had mentioned this morning, we actually sort of shifted all of our development models around the company to say product teams own features. So instead of the Android team building photos, we'll have photos build photos. And we realized that there might be a slight flaw to this, and we still needed some people to really deeply understand certain platforms. So we've had a small group of us focusing very specifically on what's Android like, what's iOS like, and how do we really adapt to what the platforms are offering, and understand where they're going in the market. And Android as a platform has this really long, storied history. Used to have hardware buttons. We thought keyboards were going to be a big thing. Things have changed a lot. Screen sizes are like double what they used to be. So Android is really evolving. It's evolving quickly. This is just like 5 years of history. And even in that time, the official Google recommended phone has shifted a ton. And what we see on Facebook is even more dramatic than this. There's about 10,000 different device models that are accessing Facebook on a regular basis. That's way more than the Photos team can understand when they're building their latest feature. And there's no way that we would expect them to think about this and say, cool, yeah, I'll just have like 10,000 different versions of this that run differently on each phone. So we wanted to really step back and come up with a better way of thinking about the platform and making it easier for teams to understand. And anytime that a platform is growing like this, you need to ask some fundamental questions of who's the typical person using this. Are they on a high-end phone? Are they on a low-end phone? What country do they live in? What type of bandwidth access do they have? Because they're probably not like us. They probably don't have a high-end phone. And that's probably only the tip of the iceberg about really building the right product for them from a user experience perspective or from a technical perspective. So we sent people around the world, and in the past couple of years, we've sent research teams to tons of different countries spread everywhere, just to try to understand what's really going on in emerging markets and how these people are using their devices differently. So we had people go and buy phones, go to these mobile markets, understand how you buy a SIM separately from a phone. This transaction took place through a cage. We were buying like $400 worth of low-end Android phones. And they're showcased in a much different way than you might expect walking into a Verizon store. So everything about purchasing a phone in the developing world is significantly different. You're paying less, you're getting a different type of phone, oftentimes they're secondhand. There's so many differences, and I'm gonna get back to that in a second. But we also just talked to people, and we asked them what their daily lives were like, how they used Facebook, why they bought their phone, what motivated their purchasing decision, how long they were gonna end up keeping it for. Everything about how mobile plays a role in their lives. And when I say mobile, there's really only two things in the developing world. There's some feature phones that these people have been used to using for a very long time, don't generally have any kind of internet access, and there's low-end Android phones. And there's aspirational Samsung S5s that everybody wishes they could own, but some people haven't even heard of an iPhone, or they never see an iPhone ever because it's just too expensive for these people. So there's three big categories of drastic differences. The first one is just in the devices and phones that they're using. It's not new phones like we're used to. It's older generation technology and often second-hand phones. And they're paying, say, $100 might be a higher-end phone compared to our phones that start at $600 unlocked. So just very, very different phones. And the big thing to focus on here is second-hand and last generation, because that's what these people are really using. And so you can't assume that upgrade rates are naturally going to take care of things. Upgrade rates are going to be lagging significantly behind. The next element of this is data plans. Most people are on prepaid plans where they're loading up a certain amount of cash based on their latest paycheck. They may not get paid regularly, and that's part of the reason why. There's also been a struggle by carriers in developing countries to figure out how to sell data to people. It became relatively obvious in the US when the iPhone started taking off that we could sell megabyte and gigabyte based plans. But they haven't been able to make the same case in developing markets where the internet isn't necessarily a given. The idea that I want to access the internet may not be a pre-established fact. You need to prove to somebody that it is valuable for them to be on the internet. And so carriers are starting to explore things like time window plans, access the internet for a week, and they impose data caps behind the scenes and throttle your speeds, but they're selling it in a fundamentally different way because you need to show somebody that there is value in being connected to the internet from the thing that's in your pocket. The last one is cell networks, and this relates very strongly to the business model case. It's really expensive to spin up a cell network, and it's even more expensive when populations are less dense. So we're used to great LTE networks that are really well maintained, and AT&T and Verizon have strong competition, so they have strong incentives to continue upgrading these. That's not true in most places. There's barely 3G penetration. It's congested networks, and even Wi-Fi tends to be based on a slower landline connection where it happens to be available. And public Wi-Fi often suffers the same congestion issues. So everything about accessing the internet is a lot different in these types of markets. So we started thinking about which problems we could tackle that were tangible to a Facebook user. And these are the three big categories that I'm going to spend some time talking about. Slow phones, small screens, bad networks. The biggest of this is slow phones. And specifically thinking about the fact that with hundreds of mobile engineers around the company, how do we actually get teams to care about specific classes of devices? How do we make sure that people are optimizing for that low-end Android phone that you can buy for $60 in a mobile market instead of just a Galaxy S5? And how do we do this when, of course, there's 20 different teams doing it? So we came up with this abstraction called year classes and just ask in what year would a phone have been considered high-end based simply on its CPU, its number of cores, and the amount of memory in it. Because that should be a reasonable gauge for performance and the type of performance that our app really needs. So the most popular devices, when you break it down by year class, give you a pretty cool picture. In recent years, it's mostly flagship phones. You notice that Samsung really dominates. But when you go back to 2010 and 2011, those phones weren't actually released in 2010 or 2011. They happen to have similar specs to it, but the LG Optimus L5 was released in 2012. It just happens to perform really similar to a bunch of other phones that are also dual core and also single core, also have 512 megabytes of RAM, and also have similarly clocked processor speeds. So this gives teams a small number of buckets to think about the way that their app is performing, and then we can start to cut all of our product metrics by it. So this is the % of weekly users who experience a crash inside of the Facebook app. You notice that it's pretty good in 2012 and 2013, but when you go back in time, it gets proportionally more crashier. The reason for this is because these phones had lower amounts of memory, smaller Java heap sizes, and we were causing out-of-memory errors. So it's a light abstraction on top of actual device specs that helps you drill into a problem, or just broadly categorize people into something that's easier to understand when you don't necessarily know where to be searching yet. And it lets us think about who's really the typical Facebook user, because 2011 is the largest bucket of phones. More people are running this low-end Android hardware, and we really need to stop calling it low-end. These are typical people. This is the average phone around the world. It is a dual-core phone with less than a gigabyte of RAM. So we've also started applying it when we're thinking about new product redesigns and such. This is a redesign of the comment flyout on Android. It's this really nice animation that you get to from Feed. And when we first rolled it out, we noticed that generally commenting on the website was up. More people were engaging with this. They were opening it more often. Wonderful things were happening. We were ready to roll it out. Then we cut all of the metrics by year class. And we noticed that for people on low-end phones, it was actually a negative experience. We promptly unlaunched it to them while leaving it rolled out to just high-end users, and redesigned a version of it that used lighter animations that were more friendly on the types of hardware that those phones had. And we're able to launch a version of it that is functionally the same, gives you the same type of UI, but a slightly different animation and slightly tweaked experience that is positive for everyone. And we're starting to apply this lens to all of the experiments that we run and all of the features that we work on to make sure that even if we continue improving our aggregate metrics, we're not leaving anyone behind. And we're making sure that it continues to work on all types of phones. The next issue is screen size. And there's certain places inside of our application today that are relatively well designed. Newsfeed presents largely the same information. It has a little less space. It's very scrollable, and your default nature while using it is to scroll. So it's not in that bad of shape. Timeline completely loses functionality. It shows me a very blurry version of my cover photo and my name. And Events shows me no current events. To be fair, it doesn't on a high-end phone either. And it actually, don't worry, I'll redeem them in a second. It actually loses the plus button. You couldn't create an event on an LDPI phone for a while. And this is about 10% of the people that we see coming to Facebook who just didn't have this plus button because the menu bar code was designed to throw things out in order to have enough space for text titles. But nobody necessarily went and tested every edge case on every single phone out in the wild. So when you actually look at the screen size distribution, though, it's not like there's any specific part of it that you should just lop off and ignore. People on small phones are still out there. And admittedly, it's decreasing slightly over time, but we're really seeing people converge towards the 480 by 800 or HDPI bar as the most common screen resolution that Android has. Growth in the high-res buckets is also happening, but when you start to cut it by specific countries, you notice that there's going to be entire segments of the population that will always be on these lower resolution screens. And so that necessitates redesign, and it necessitates rethinking some of the assumptions in products and pushing our design teams to question the density of information, the importance of certain elements, and ways that we can provide the most important parts of each experience as quickly as possible. So now Timeline actually shows you the information that you need, gets rid of a little bit of Chrome, it gets rid of some of the less useful information of the cover photo, but you can still access it. And Events also reprioritizes everything that it's showing, moves its navigation switcher to be a smaller component, and again, we get rid of some of the overall application Chrome. So this just makes for a dramatically better experience for somebody who's on a very non-responsive touchscreen that's probably not going to be super accurate with exactly where they touch, and don't have that much space. You need to get as much content above the fold as possible. The next thing, which Andrew's going to touch on a bunch more in a second, is just generally looking at connection speeds around the world and also starting to consider the cost of internet access around the world. In the US, there's about 70% 3G or 4G penetration. In India, that's 7%, and in Brazil, that's around 38%. So there's just dramatically different levels of connectivity, and even where somebody has the same level, the average latency is a lot worse. India is 500 milliseconds. There's actually an asterisk to that. It's because most of the country is on really crowded 2G connections. So their 3G is actually relatively high quality compared to what most people are experiencing. That's because 3G data access generally costs twice as much as an equivalent amount of data on 2G. So most people are being priced out of accessing that while operators are trying to recoup the infrastructure costs. But it's just really important that we can continue in all variables to consider these different scales and to consider the fact that not everyone is on a fast phone. Not everybody is on a fast network. Not everybody is on a large screen. And how do you make sure that the experience degrades at each one of those cut points? So takeaways. Android is the world's platform. Increasingly, it is becoming the first point of internet access for most of the population and will continue to be that way, whether it's Google Android or another form of Android. You are not like other people, and they're accessing the internet in dramatically different circumstances than you. And the way to make things good and acknowledge the way that the market is playing out is to segment smartly. And that applies both for making a good product and as an organizational tool. It's really challenging for us to go to every team inside of Facebook and say, you're doing this wrong, and you're doing this wrong, and you're doing this wrong, without also providing them with tools that help them do the right thing and help them be aware of how to look for the places where there's opportunity. Once we started showing teams graphs of how they were performing on different phones, everyone reprioritized their roadmaps. Because as soon as you see that you're 3 times slower on certain phones, you want to fix it. And so providing those tools is just as important as exposing the problems. And next up, Andrew to talk about some of these tools.
Thank you, sir. Good luck. Thank you, Chris. I'm Andrew Rogers. I'm an engineering manager in the Facebook Seattle office, and I work on our Facebook for Android application. As Chris alluded to, the network characteristics and the costs of network in other countries are not what you're getting here in the US. Today I'm going to talk about changes that we've made to our Facebook application for Android to make it perform better on these different types of networks. We're going to cover 3 areas: image download sizes, dynamic network quality detection, and I will touch on prefetching content. First, reducing image download sizes. So the thing to note here is that image data dominates the bytes that we get downloaded to, or that we download in the Facebook application. It accounts for 85% of total data we download to Facebook for Android, and even 65% in Messenger. So clearly, if we're able to reduce the size of images that we download, we could save quite a bit of data. Not only that, smaller image sizes will result in quicker downloads, so the images end up on your device more quickly, especially on high latency networks. First, and most obviously, you can scale down your images on the server before you send them down to the client. Sending a large image to the client just to have it resize it locally to fit on a small screen is kind of pointless. It wastes a lot of data. It takes unnecessary time. Instead, you could choose to send smaller images, a thumbnail, a preview, and then maybe only a full image when the user actually needs to zoom in on it or share it over email or something like that. Many times users will never need anything more than just a thumbnail or a small preview. Oh, just to reinforce the scale here, this image is 960 pixels wide. The image of the kitten, that is. On top of that is a phone whose screen is 240 pixels wide. You'd have to pan around quite a bit just to see the entire kitten. So you might as well shrink it down. Still super cute. But the savings is significant. So scaling down a 960 pixel image to fit on this screen, 240 pixels wide, saves 86% in size. Even on a larger 720 pixel wide screen, which is also a popular size, you're still saving 23%. So image scaling can be a little bit of a balancing act here. Smaller files download more quickly, but if you download too many different sizes, you're going to end up using more data potentially. So if you had an image that was displayed in many different ways throughout your app, and you downloaded a unique image for each one of those instances of a different size, you may end up downloading more data than you did originally with just a single image. In the Facebook application, we've chosen 3 primary image sizes that we download per screen resolution. There's a preview image that we download, which is what you're going to see in your news feed. We'll also download a smaller thumbnail image for profile pictures and a larger one that you will see in photo stories. It's also worth mentioning that since screen sizes are generally getting bigger, it's trending that way at least, scaling images isn't as effective as it used to be. This is something we've done over the last year in Facebook app. It isn't paying off quite as much as it was at the beginning. Still worth doing. Another thing you can do is change the format of the images that you're downloading. So this table lists several of the popular formats. You might expect that in the Facebook app we would be using JPEGs for most of what you'd see in your feed. In actuality, 90% of the images we're sending to the Facebook app for Android use the WebP format. So WebP is a relatively new image compression format. It was released by Google in 2010, and it's really well supported on newer Android OSs. So why are we using WebP? In our testing, we found that it saves 7% download size over JPEG for equivalent quality test results. But by moving to WebP and by tuning the quality and compression parameters, we saved over 30% with the previous JPEG compression that we were using. And that's really significant when you think about it. In our testing, there was no noticeable change in user perceived quality. Kitten again. This is a comparison of JPEG versus WebP. When I was putting this together, a couple of us were looking at it. We really couldn't tell the difference. Honestly, I couldn't choose which one I thought looked better. I pulled both of these directly from the Facebook servers. The one on the right is WebP. The one on the left is JPEG. See, I can't tell the difference. But the cost savings is pretty significant. It's over 25%. Another thing worth noting is that WebP supports other functionality not included in JPEG, like transparency and animation. These are things that we use in our stickers product, which you may be familiar with. We used to download stickers using PNG format, uncompressed. Switching to WebP saved 80% in the size there, which was fairly significant, as you can see in this sticker image. So I mentioned before that WebP is well supported on newer Android versions. We found that all the functionality we needed was only in Jelly Bean and newer, so Android 4.2. For older versions of Android, we're still downloading images in WebP format, but we include libraries in the application to transcode them on the client once they're downloaded. So we're still getting the cost savings, but we are transcoding to JPEG and PNG before we cache them and before we render them. If you do want to avoid the transcoding cost, you could do something different. You could continue to use JPEG, something like the Moz JPEG 2 encoder. It's fully compatible with JPEG. You get better compression results with a pretty small, pretty reasonable reduction in file size. So decreasing image sizes is pretty significant, but we found that we really needed to have a way that feature developers working on the Facebook for Android application could know whether or not they were on a good network or a slow network. So before I get into the details, this graph shows network round trip times that from information that we gathered across four different network interfaces in 3 different countries, the US, India, and Brazil. So the thing that stands out most here, the US is the red bar, is that even on the exact same network technology, we've got 2G, 3G, LTE, and Wi-Fi, the connection speeds in the US are 2 to 3 times faster. I guess it's 2 to 3 times slower in the other. This is kind of interesting, though, because you'd think same network technology would have similar speed. Another thing that's interesting to note here is that the LTE connection speeds in Brazil and India, the other 2 countries here, are actually faster than the Wi-Fi speeds in those countries. So the details here, it points to the fact that you can't just base the connection speed on the network type that you're connected to. Android surfaces that information, but simply looking at that is not sufficient. So we wanted to dynamically monitor network quality in the client. We really wanted a tool that developers could use, a lot like your class, which Chris described, that would allow them to determine if the network was fast or slow. So we built this into the client. We measured the throughput on all large network transfers, which ends up being mostly images in practice. The Facebook servers provide a round-trip time delay estimate in the HTTP headers when they send back for basically every response. And the client maintains a moving average of these values and attempts to determine the connection quality. It then provides a rating: poor, moderate, good, or excellent. Those are the current values we're using. Those could change. Those values, poor, good, moderate, excellent, those are then provided to feature developers that are adding features to the Facebook application. And they can adjust their behavior accordingly if the network is slow. So some of the things that we're considering doing on slower networks, these are things we're investigating. Increasing the image compression. So I said before, image compression can result in smaller files, quicker downloads, use less data. Why not do it even more when you're on a slower network, and we know you are? Issuing fewer network requests in parallel, just so we don't saturate the network, and the requests you have out there will return more quickly. Disabling features like autoplay video, things that won't work very well on slow networks, and also prefetching more content. I'll touch on that in just a minute. So that's good, but we're still all here in Silicon Valley. We have fast LTE connections, or we're on Wi-Fi at work. How do we know this stuff works? How do you actually test your features out? How do you test your app out on a slow network? So we've built an internal tool at Facebook called Air Traffic Control, and it lets developers configure their local Wi-Fi connection to emulate different network conditions. So we have predefined profiles that developers use to simulate connecting in a different country. You'll see here an example. We have a rural and an urban profile, different for India, and we have Brazil. There's other profiles here as well. And they're fully configurable. Each of these profiles is configurable with the bandwidth, the round-trip time delay, packet loss, separately configurable for the uplink and the downlink. So we found this to be extremely helpful in basically finding unexpected behavior in your application when it's on slow networks. So before I wrap up, I want to briefly call out some of our learnings on content prefetching. So when I say prefetching, I really just mean issuing network requests for content ahead of when they're actually needed on the device. So we know that prefetching content is especially important on networks with high latency. If you wait to kick off a download request for an image, for example, if you wait until the viewport that's going to display that image is in front of the user already, and you're on a network with a high latency, say a second or more, the user is going to be staring at a blank screen for quite a while. So if you could somehow get that prefetch request out early, have the content there before the user saw the view, or at least a little bit ahead of time, they'd be waiting less to see their content. One thing that we do in the Facebook app is we issue our network fetch request for the feed early during startup. This allows us to parallelize waiting on the network with other initialization that happens while the app is starting. Other things to consider with prefetching, well, you don't want foreground network requests to be blocked on background network requests. If you're prefetching a bunch of stuff and saturating the network, you could actually make user responsiveness worse. So consider having some sort of a priority queue where the network requests for your foreground experience get serviced ahead of those for the background or for prefetching. Also, you need to carefully monitor for overfetching and just use of device resources. You could fill up the disk. You could end up wasting a lot of the user's data plan. As Chris said, this costs people money. Basically, things that you should consider when you're prefetching. In summary, scale your images down to an appropriate size before you download them. Consider alternative image formats and tweaking compression and quality knobs to have a result that you're happy with and to make the download size as small as possible. And even adjust your app behavior on slower networks. Like we said, networks outside of the US can be 2 to 3 times slower than what you are used to using here. And with that, I will hand this off to Tyler, who is going to talk about Instagram. Thank you.
Hey everyone, my name's Tyler. I work on the Instagram Android team. I'm going to talk about some of the ways that we've improved Instagram to work on these lower performance phones, smaller screens, in emerging markets. We'll cover 2 things today. The first is design. So we basically rewrote our entire app UI this year, focusing on performance and on better performance across the wide range of screen sizes that we see on Android. And cold start. How did we get our app to start up super fast so that people on low-end phones have a great experience when they tap the Instagram icon? So we'll start by talking about design. This is what Instagram looked like when we launched. This was a little over 2 years ago. April 2012. And so for a little bit of history, the app was built by 3 people, a really small team, 2 engineers and 1 designer. And it was built in a little over 4 months. A really fast timeline. People were clamoring to have Instagram on Android, so we wanted to get it out to people as fast as possible. And actually, the entire Instagram team was really small at that point, less than 15 people. And so really, to keep things simple, to be able to get Instagram for Android out really fast, we basically kept the same design as the iOS app at the time. And we actually really only had 1 designer on the team, so it kind of made sense. And this is what the iOS app looked like. You can see it's pretty similar. This is the era of iOS 5, luscious gradients, lots of UI. As most of you know, Apple has since moved on. They introduced iOS 7 and brought flat design to the world of mobile, or at least to the world of iOS. You know, other platforms had similar things, but Apple did it in a very unique way. And we updated our app for iOS 7. And you can see how much simpler it is, right? Basically stripped out all the UI, took out all these boxes, no more gradients, no more shadows. It's a lot simpler. It's a lot more beautiful to look at. And from this experience of adapting the app to iOS to flat design, we took away a couple learnings. The first was that flat design is great for developers. It's really an opportunity to do less and to write code faster. You're writing less UI, and so you're going to be able to ship products faster. The second one is that it's a lot more performant. At the same time that you as a developer are doing less, the phone is doing less to display your UI. And so we wanted to bring these learnings back to our Android app and to really update that for the modern ecosystem of flat design. And so we decided to embark upon a redesign project at the beginning of the year. And our goal is really to simplify and polish what we already had. We didn't really want to change the app drastically. We didn't want to rewrite the navigation pattern or move stuff around. We just wanted to take what we had and make it more beautiful and more performant. So yeah, we had 3 goals. The first one was to make it flat, and by doing so, make it faster. And we'll talk about the ways in which we did that in a couple minutes. We wanted to be more screen space conscious. So as Chris talked about, there are so many different screen sizes. And we knew our app worked well on some of them, and different parts of the app worked better than others at adapting to the screen size. We really wanted to take a fresh look at every screen in the app and say, how could we better adapt this to all the different screens that are out there? And the third thing is we wanted to make it beautiful. This really underlies everything we do at Instagram, and that was an important part of what we did. So I'll show you some before and after pictures. A lot of these are going to be somewhat similar concepts as what Chris talked about with the Facebook for Android app. So this is the before and after, the main feed when you first get into Instagram. This is the first screen that most people open up onto. And there's a couple things I'll highlight on this slide. The first is that we basically took everything out of the Chrome. You know, we took all the gradients out, all the glossy buttons, all the shadows, and we're left with solid colors and flat shapes. And the second thing is that for the comments, we took out the little comment icon and made the comments the full width of the screen so that there's less UI. People on really small screens have more room to read the text. And the overall effect is one of just dramatic simplification, right? On the left side, you know, the Chrome is kind of garish. It stands out. It really distracts your attention away from the beautiful photos that we want you to be looking at. And so we want our UI to fade into the background. You know, we took away, we went to outline shapes instead of, you know, gradient buttons for the icons, and really just tried to make the content the primary thing on the screen. The second thing we looked at was the creation flow and editing flow. So when you take a photo or take a video and then edit your photo or video, the layout on the left is really actually optimized for the smallest of screens. It doesn't work well on medium or large size screens. And that's because all your controls are at the top of the screen. So for the camera, things like the switch camera button, and in the editing flow, your filter controls are often at the top of the screen where they're not easily accessible for your thumb. And so we actually forked our layout here. On really small phones, we still do the layout on the left, but on medium phones, such as the 480 by 800, that's the most popular screen size, or even larger phones than that, we actually bring the buttons down to the bottom. And so it results in a dramatically better experience because you don't have to be touching buttons at the top of the screen. We found small optimizations all over the app. our goal was to remove unnecessary UI and give more of the pixels over to content. So on the search screen, we discovered why have 3 layers of Chrome here. We can take the search bar and move it into the title bar and really collapse it down to 2 layers. So on a really small phone, you're getting a lot of space back, especially with the keyboard up to view content. And lastly, our old friend, the Galaxy Y. This phone is really amazing. If you've never seen one of these, you really ought to get one. It's unbelievable what your app looks like on this thing. And this screen is so small. It's 240 pixels wide. And we looked at the old design on this, and we said, wow, there's a lot of the screen that's being taken up by the tab bar and the title bar. Is there any way we can do better? And it was a lot easier to tweak these UI components when they were just solid colors. We can just adjust the height of elements. We don't have to cut new assets for gradients. And so when we did the redesign, we decided to try slimming it down. And we had the phone right there, and we tested it out. And it was just as usable. The tap targets were big enough to use. And as you see, we get 20 to 30 pixels back on that photo, which is really nice. So why flat design? I said it was performant. Now I'm going to try to prove it to you. One thing you can do that's really great if you have a flat design is you can do asset tinting. So in code, take this gray heart shape and turn it into a red heart. This is actually being touted as a new feature in the latest Android release, which is Android L. Not even out yet. It's out as a preview. But the big secret is that it's actually possible in all versions of Android shipped up until this point. And it's also possible in iOS. They give you this class called a color filter, which you can apply to a drawable or an image view. And specifically, we use a Porter-Duff color filter, which is designed to, you can actually do most of the different Photoshop blending modes. We use it in a much simpler way. We use it to just turn shapes that have alpha into other colors. Why would you want to do this? Why would you want to tint your assets? The first thing is that you're going to end up shipping fewer assets. If you have assets with different states, pressed states, selected states, you don't have to ship those anymore. You ship one shape. And your APK size becomes a lot smaller, which is great if you're on a slow network. You don't want people to wait to download your app. You want to ship the smallest app you possibly can. The second thing is that you're going to load fewer assets. So your UI is going to display faster, and you're basically using less memory to store these bitmaps in memory. If you think about it, when you start up your app, every asset that you're going to display on screen has to be read off of the flash memory and decoded into a bitmap. And the less that you're doing that, the faster it's going to be. And I'll talk about the numbers in a second. The last thing is that you really have faster iteration times. If you want to change the colors in the app, or if you want to do new development and you already have the assets there, you just need them in new colors. You don't have to put files in the app. You don't have to talk to a designer. You just have to get a color value and recompile, which is really, really nice. So yeah, this is what Instagram went from before the number of assets we had to load to display our UI to after. You can see we had to load 29 different assets to display just the tab and the title bar. This is different states, pressed states, unpressed states, gradients, basically the lot of it. And then afterward, we had 8 assets that we needed, basically just the shapes to display the icons and the Instagram logo. And everything else is drawn in code as solid colors and rectangles. And that actually shaved off 120 milliseconds off of our cold start time, just doing that. And that was really awesome. You'll see how that relates to our overall numbers in a little bit. And this is just the cold start impact. Really, the entire app got faster. Every screen we were doing less. We're loading less assets to display that screen. And the whole app just felt like it got peppier when we were done with its redesign. And that actually got reflected in the user reviews as well. People said they loved the design. They said it felt fast. People really, really liked it. And I think I took a couple things away from this. One is that people understood the speed gains. The second is that people love it when you actually take your app and design it appropriately to fit the platform that you're on. And yeah, it was a really good, awesome result. So we'll talk a little bit more about cold start now. And we'll talk about some of the other things that we did to get our cold start way down. Let's start with the numbers. So about a year ago, Instagram 4.2.4, this was our cold start times on one of the lower end phones in the market and one of the most high end phones. I just tested these numbers the other day. with an older version of the app. These are pretty good numbers, right? This is pretty fast, but a year ago, we were like, we can do better than this. And so over the past year, we've cut these down in half to the point where our app starts up in 1.5 seconds on a Galaxy Y phone and under half a second on an S5. And I should mention that this is the time for the app to start up and become responsive. You can actually use the app at this point. This is from tapping the icon to I can click around the app and it works. And the great thing about this, especially on these higher end phones, is that the app basically starts in, it's imperceptible, the cold start difference to the warm start. So you really can't tell whether Instagram's starting from scratch or it was already in memory. And even on a Galaxy Y, this is, Instagram is one of the fastest apps to start on the phone. So how did we get down here besides removing all the assets from our UI? You got to profile the app, right? You got to figure out what is slowing your app down. And there's two basic ways you can do this. You can do method tracing, so you can use Android's trace view tool, or you can put timing statements in your code. Both of these methods are a little bit fallible, so method tracing will tend to overcount the time caused by smaller methods just because of the overhead of logging when a method starts and stops. Timing statements, because you're measuring wall clock time, you're not really measuring time on thread. So if your threads are swapping in and out, you kind of get an imperfect picture of what's going on. But if you use both these methods and your intuition, you can get a pretty good idea of what's slow. And after that, you want to fix it, right? You want to take whatever is the slowest thing in your app and fix it. So you can either remove it from the cold start path, lazy load it. You can rewrite slow code. So one example of that is we had some slow JSON parsing code that we rewrote to be faster. Or you can defer things to a background thread. So if you're doing stuff on the UI thread that can be done in the background, we want to do that as well. And then once you do that, you want to go back to step one and start over again, figure out what's the next slowest thing, and keep going and iterate till you get your cold start to the time that you really want it to be. So when we did this, we used the timing statements to find out that we had a lot of really heavy singletons in our app that were causing a lot of our initialization time. We were initializing these all before the app could start up, the HTTP client, the image cache. And our great realization here was, well, we don't really actually need an HTTP client or an image cache to show the app UI and to have the app start up and be responsive. We can kind of load those in the background in parallel. And so we came up with this method that we call two-part lazy loading. Two-part because we want to initialize these objects lazily, but we don't want to break the programming contract of a singleton whereby it's always available to the app. We don't want to have people that are writing code have to check whether or not the image cache is initialized yet, because that would make the code complicated and brittle. So what we do is we create the object on the UI thread. We create the object enough so that its public API is intact and any developer can use it. And then we defer the hard work to a background thread. So in the case of the cache, this is opening and reading from disk storage. For the HTTP client, loading certificates off the disk to be able to do SSL, cookie store, deserializing cookies. And that basically makes the UI appear on screen much faster. We're deferring hard work till later, but we didn't mess up the programming model of having these nice, simple singletons around our app. For an example of what we found out through method tracing, this is an example trace of the cold start of our app from a few months ago this year. And one thing that we noticed that really surprised us is that about half these threads came from a single web view in the app, our news view. And the news view is the page in Instagram that shows you all of your likes and comments. And it was originally written as a web view. We thought that we'd want to be able to ship updates to it faster than we were shipping the Instagram client. And now, it was a product requirement that we load this view at startup. So when you load Instagram, we want to show you this, how many new likes and comments you have, right? That's the most exciting part of using a social network is interacting with other people. So we pop up this little orange bubble. It says you have 5 new likes, 10 new comments. And then once you tap on that, we want to be able to immediately show you this expanded view. Well, unfortunately, the web view, really, you have no control over it, right? It has its own network stack. It has a separate image cache. It's going to do whatever it wants when it wants to. And as an app developer, I really have no control over that. So we took the hit. We converted this to native. It took probably 2 to 4 weeks. This was not an easy thing to do. There's a lot of different types of stories in this view. But after the native conversion, we saw that there was a 30% drop in cold start time across all versions of Android out in the wild. This is from data out in the wild. So what are the lessons learned? Fast cold start times are achievable. You know, we thought our cold start times were really fast about a year ago, but then they got even faster. And this was through profiling and you know, diligent profiling of the code. And I'm not telling everyone to remove web views out of your app. You got to profile your app and figure out what's slow about it. Using pixels judiciously. This is really, really important. People in other countries are using dramatically smaller phones than we are here in the US. And it's really important to evaluate every piece of UI you have and whether it makes sense or not on screen. And lastly, mobile phones love simple design, and also mobile developers do too, because it's a lot easier and it's a lot faster. So that's it. Thank you.
So Chris, Andrew, do you want to come up? So we have time for Q&A. So any questions you have back here?
Those lights are so bright.
They're so bright.
Yeah, so you talked about emerging markets, but in, say, Japan and South Korea, you actually have much faster. So the opposite part of it, do you do anything special to actually make the experience much better on amazing networks?
I think in general, I mean, we have pretty fast Wi-Fi at the office. I think it's fairly easy to get a great experience on fast networks just because those are the networks we're so used to. I think really the difficulty is optimizing for those slow networks. Now, not at the expense of a great performance on Wi-Fi. That's where it becomes really difficult. Is you want the app to be great in both situations.
And frankly, I think that like fast connections are simply able to mask areas where we have optimizations that we need to make. So one of the things that I noticed when we're on our office Wi-Fi is that the fact that we're issuing a ton of concurrent requests in the application without thinking about how much our actual upstream pipe has available doesn't impact performance, and it does in other places. So the optimizations that we're making can really apply to any connection speed, and when you start to go in and add actual prioritization, make sure that you're bumping up things as soon as they enter the viewport, like those things all still matter for high-end connections. And we're also thinking about the fact, like, hey, if you look totally unconstrained on bandwidth, maybe we should serve you slightly higher quality images. Autoplay video is a feature that we have rolled out for people on different connection types now, and we tune that for different countries as well in order to make sure that we're like respecting the availability of a pipe.
That's why we have that excellent grading at the high end of the rating thing. So yeah, definitely something we're thinking about.
I was really interested to hear about all the optimizations that you did for loading images, especially on limited phones and slower networks. I was wondering if you had projects like that for uploading images and uploading content to a network also.
We did a ton of optimization in this, like at the end of last year as well, on upload reliability for photos in both the Android and iOS apps. The biggest lessons learned were aggressively retry when there's a failure. A lot of the times we would find that failures were, at this point, most of our failures are really just something wrong with the pipe and they fail immediately. Anytime that something doesn't go through midway, we just start retrying. The other really important thing for image uploads has been client-side resizing and encoding. So instead of sending a 2 megabyte photo, we, in the past, would at least do recompression on the device. Now we also do resizing on the device, which in certain instances also saves server transcoding costs because we already have a pre-compressed image. So the main lesson there is just fewer bytes over the wire and retry, retry, retry.
All right, there's a question that you use WebP on Android. Have you used WebP on iOS, and what's the experience for that?
Just on Android at this point.
So my question is so with images, you guys resize it. Did you guys apply anything similar to video?
I don't know exactly. On video right now, we've got a couple different compression qualities and a couple different resolutions that we re-encode to. The short answer with images and video is that we're doing transcoding on the server for both quality and resolution. I forget exactly which bucket sizes we picked for video. There's slightly fewer, but it's increasingly becoming a larger part of our app experience. So we're figuring out what better encoding technologies we can use now, and whether we need more whitelisted sizes to be able to select a smarter one for each client.
We have 2 buckets for video on Instagram and 2 buckets for images as well as thumbnails.
Hi. I just wanted to know, do you do any A/B testing in the emerging markets to get the feedback?
So we do A/B testing on pretty much everything that we roll out, and we don't tend to gate things specifically to certain regions at this point. Most of our optimizations we want to work for all billion people. And then we do a lot of analysis to make sure that we're understanding the impact in specific areas. So we do occasionally find that product changes perform different in certain regions, and have like a general understanding of how certain regions behave differently in terms of engagement usage. So we don't often roll things out on a specific basis like that unless there's a really specific local need, but we're super careful in the analytical stage of looking at an experiment and making sure that it's positive for everyone and not like secretly negative for one group, but up for everyone else.
I have a question about the performance and whose responsibility it is. I noticed that you talked about different feature teams and make sure they understand the impact of some of the things. Is it each vertical is responsible for monitoring performance, or do you have a central team dedicated to monitoring all of that?
I'd say we actually sort of have both. Yeah, teams would be responsible for the performance of their individual features end to end, but we do have kind of some core teams across mobile who do spend a lot of time analyzing performance, looking for where issues are, and helping other teams with the issues that they find, and they have a lot of expertise in optimizing things.
We've gone through different approaches here too. Like, I'd say it's sort of recent that we have both teams caring about everything. A playbook that's worked well in the past for speed on the www side of things for us was having a core team and infrastructure that helps coordinate general performance problems, and is really good at doing instrumentation, identifying where problems are, and working with product teams in whatever capacity is needed in a specific case. But we're also finding specifically on mobile that it's really important each team own both their core engagement metrics, but their core reliability and performance metrics, data usage, how fast their feature starts up, reliability for their product, whether it's causing any specific crashes or something. So having the people who are really good at the playbook and understand how to go look, diagnose, and fix certain problems, in addition to making sure that every team is owning their full product end to end and making sure that they know how to and are incentivized to fix problems on it, I think both are really, really important at our scale of organization.
I have a question about how you publish the app, or actually whether you have multiple versions of the app depending on the device.
I think we publish like 20 different APKs for the Facebook app. They're cut by API level, screen size, and processor architecture.
Yeah. Similarly for Instagram, we do the same thing.
Hi. I have a question on the original image source. Let's say, do you have the single image what you share across iOS and Android? And the second question is, let's say the full image needs to be displayed and this is low resolution device. Do you kind of know about that in advance and you are minimizing the image size, you're kind of scaling it on the server side?
So on the server, we have multiple resized copies of the different images. And we tell the client about the different sizes that it has available. And so it is up to the client to decide which size do I want to pull down for whichever view it's rendering. So the images would be shared across platforms. So the iOS client would be downloading same images as the Android client with different sizes depending on the different screen size. And I'm sorry, what was the last part of the question?
The second question is, let's say the original photo was done on a high resolution camera.
Sure.
And you're loading this on a low end device. So, and you want to see the full image, right? So would you kind of evaluate the capabilities of the phone and based on that don't send, let's say, huge image to the device which is practically not capable in display?
Right, yes. Yeah, we would send a smaller version basically for smaller screens.
One last question here.
Hi, I would imagine to support different networks,
in emerging markets, you guys would do a lot of caching. Can you tell us about a little bit more about your caching stack? Did you go for any open source projects, or what are the challenges you faced building it?
Which level of caching?
Say not at the HTTP cache, but at a higher level. Say you want in the morning we're talking about iOS, where we're talking about more model layer, immutable models, and component level caching. What is the equivalent on Android?
I don't think I have enough to talk about that here. Come grab me afterwards in happy hour and let's chat. And whoever asked the question about WebP on iOS, Ari tells me that I lied about that. So we have done some WebP on iOS stuff. I'm not familiar with it.
So ask Ari about it.
Yeah.
On that note, let's give one final applause to our speakers here. I think it was fantastic. And I'd just like to thank all our speakers. You know, everyone put in a ton of effort, and I think it shows. And so we are done. I hope you guys found it as useful as I did. And why don't we put that URL on screen? Just a reminder, this is the Facebook group. We're going to try to make it as active as possible. We're going to post all of the videos, and the speakers will be active there answering questions. So thank you all for coming. There's a happy hour now on the 4th floor, and please join us. And thank you for coming to AtScale.